So this showed up as the markdown, the plain text markdown, and then when you click run, it does the display. So there's two different types of cells. There's a markdown cell, which is what we just clicked into, and then a code cell. So our code cells are going to look something like this, and you'll note that it has the IN next to it, which is which basically means this is input that's being run. So once we get farther into it, you'll see numbers next to this, and this means that that is what's being, or what has been already run as code. So, for example, print hello world will give you this output, hello world here. And if you want to run this, you'll click the run on the top, and that's the output that it'll give you. Or you can click shift enter, and it'll do the same thing. So your Jupyter notebooks won't have this handy numbering on the side quite yet. What you can do is you can go to view and toggle line numbers. And if you click that, for mine, since I already had it on, it turns it off. And then if you go view toggle line numbers, it should show up. And this is really useful for when you're encountering errors. When you get the error, it'll tell you what line it's experiencing the error. And sometimes it'll say that it's experiencing error in a line that doesn't actually have the error, so it's somewhere around that area. And we'll get into errors and debugging later on in the day. So these two different boxes, they have pound signs in front of them. And these are essentially comments. So when you run this code block, nothing will be outputted below the line. And that's because they're for humans to read only, and this is for documenting the process. And you'll see this on occasion in the code blocks that we're using. And this is just, again, for like coming back to it, like regardless of whether or not it's like later in the day or like in a month, in years. There are some codes that you'll see online that have zero documentation or zero comments whatsoever, and you're like, I don't know what letter or what does this mean? Like, what are we doing here? And so it's really important when you're programming to make sure that you're documenting your process. And sometimes you'll see very simple explanations of what's happening in the code, but as the code gets more and more complex, you'll need those to come back and remember what's happening and why you did this. Or like, for example, if you run into an error and you're like, okay, I know that there's an error here, I'm going to come back and fix it. And then you're like, oh, the code, I didn't make a note of where the error is, and now I have to go find it all over again. So this is that same line of code that we had before, but now it has a pound sign in front of it. So when we run this section, there's no output, and that's expected. So, so we've only been working with pre-existing cells that are in the notebook. So for the first exercise, we want to insert a markdown cell and write one thing that you hope to get out of the Python Bootcamp. I haven't yet taught you how to do that. So we go to this plus sign over here, when we and it'll insert a cell below the like blue marked area. And this right here is not a markdown cell, it's a code cell. And you can tell because on this drop down here on the top bar, it says code as opposed to markdown. So if we click on this code and we switch it to markdown, then it no longer has the IN next to it. And now this is a markdown cell where we can write what we need to and then run this block. So what questions do we have about Jupyter notebooks in general before we jump into the first basic concepts? Yes.
What would be the difference between having a code that says print versus doing a markdown?
So yeah, so we'll test it out. So if we do print, if we do print hello world, and this is in a markdown cell, and then we do run. So it just prints it, just plain text as is, as opposed to just printing out the hello world by itself. And so that, so then you know that the code isn't actually running and it's just doing the plain text paragraph. Yeah. Yes.
Would when we get back to our offices, would we be able to access a Jupyter notebook from there, or would it be, what's the process for getting into it later?
So I do believe we have access, you guys have access to your workshop accounts for at least a month before we start our next workshop. And then those that are online have access to I mean, like, and in general, you have access to my VLab. And so you can download the Jupyter notebooks that you've been editing during the workshop, and then do it later. Yeah. Yes.
So Jupyter's fully online. It's like Jupyter's fully online, meaning it doesn't require us to like download actual Python. Systems. Is that how that works?
So
Yes and yes. So yes, what we offer is all online, but you can also decide to run on your own laptop if you want. So it's usually easier to use what we have or any other service. But if you really want to, you work on the airplane, you can download on your laptop.
yeah, so I guess so the question was is Jupyter online, and how do you access Jupyter notebooks? You can download Jupyter notebooks on your own computer and like kind of install all the separate packages that you need to run Python, and it just opens in a browser. But for the cases of this workshop and my FSU VLab, you would need to connect to the internet to run Jupyter notebooks. All right. Yes.
Yeah, so in the drop down, there are a lot of options, right?
Mhm.
Back down. So what do you want? What do they mean?
Okay, so we can test them out. So for heading, this is the I guess like the pop-up that kind of shows up. So for markdown, you'll just put a £sign in front of it. Kind of like how we did comments, but the view will be a little bit different. So for example, if we run this, now it's in that bold black font that we have the session 1 in. And we can change the different signs. So we do 2, then it's slightly smaller. And then for raw notebook convert, and we run that. So for this, it's if you were to kind of want to write just a code block and not have it actually run any output, that's what the raw notebook convert does. And so those are our 4, but we won't necessarily be using the heading one or the raw notebook convert during this workshop. Good. All right. Okay, so for session 1, we'll cover the Python fundamentals, and then these questions will kind of be answered during the session and then throughout, and then also we'll talk about lists near the end to kind of get you started. So Python can be used as a basic calculator. So 3 + 5 × 4, and then we'll do the order operation. So 5 × 4 first plus 3. And so it can act like a basic calculator, but it helps if you can save the values that you're calculating into something that's kind of a little bit more memorable, as opposed to just doing the manual calculations and then like I guess similar to a calculator. So when we want to save them, we can save them to names called variables, and variables will act as a kind of like a placeholder for that value that we want. The way that you typically set up variables is you set the left-hand side to be the name of the variable that you want, and then the right-hand side is the value of that variable, similar to how we do it in math. So if you were to do it the other way, where the value is on the left-hand side and the the variable is on the right, we run this, you'll get an error. Can't assign to a literal. There's a couple different rules when it comes to variable names. They can include letters, digits, and underscores, but they can't start with a digit, and they are case sensitive. So for example, if I want to set, so for example, if I want to set weight equal to 60, and then weight with a capital W equal to 120. When I set these, they won't change, they won't produce any output because we're just setting a variable to values. But if I wanted to print these values, we'll get two different numbers. And then one of the other rules is that a variable can't start with a number. And it will give us an error. It won't give us the same error that it did last time. But invalid syntax is the error that we get. Oops, here. In terms of values that we can assign to variables, we have numbers in terms of whole numbers and decimals, or words and phrases, which are strings. So what you'll see when they're talking about the different types of data is integers are our whole numbers, floating point numbers are our decimals, and then strings are the words and phrases. And they can also just be like a single character as well. So the floating point variable will always have a decimal in it, even if it just has the decimal without a number following it. So if we print weight gram, and then we run this code, if it just has the decimal, it automatically makes it into a floating point number as 60.7. Yeah. So the strings are always notated with either a single quotation mark in the beginning and the end, or a double quotation mark. So they can be numbers, they can be words and phrases, and they can be a mix of numbers, letters, and symbols, as long as they have either a single to single apostrophe or a double quotation mark at the end. So if we run this set of code, we won't get any errors, so they've been successfully attached to these variables. This is the example that I did before, where weight with different capitalization will give us that same. Those are both integers, and then if we print those values, we'll get those different values for each of the different versions of weight. So. I'll pause. Do we have any? Yes.
So this is iterative, where it recalls what you previously have assigned values in previous blocks of code.
Right.
Retrieves.
Yes. So that's something to note also about Jupyter Notebooks. When you're running a or like typically when you're running code not in a notebook, it goes sequentially, right? And then for this, it will actually go in the order that you yourself run the blocks. So for example, as you see these numbers, these are increasing as we go down, and that's the order in which we're running this code. So if we wanted to run this again, like say we change capital W weight and lowercase w weight again, actually we've done that. So if we change it back to what it was, we want to run this, the number now will be 15. So this is the 15th like code block that we've run. So then when we go back and we want to rerun lowercase weight and uppercase weight again, we'll run this. And now it's to 60 as opposed to 128. And this is 120 as opposed to 0. So yeah, so again, something to keep in mind if you're coding in Jupyter Notebooks, the order that you are running it matters as opposed to the order that it's displayed. Because again, this is something that we'll run into in terms of debugging as well, like what's the order that you run your code in, and then also like, sorry, lost my train of thought. And so just to make sure that you like know what your values are, and that might cause errors later on. All right, any questions? Okay, so we can use variables just to say values, but that's not super useful because then we would just kind of like, we can just use it as a calculator, but we can utilize variables in Python, not only for print statements, which we've seen where we can print out the value, but we can also use it for other calculations. So for example, if we set a weight in kilogram, and we wanted to calculate the weight in pounds, we can just multiply that regardless of what the value for weight in kilograms is. When we run that, we won't get any output again, and we'll just do a print statement to see that it's changed. The patient ID here was 001 before as a string, and what you can do is you can add another string to the beginning of it or to the end of it, and that'll change the value. So for example, this completely changes patient ID utilizing the last value that it had. When we run this, we won't get any errors, but we will use built-in Python functions to kind of see what's happening for both of those variables. So we already utilized print as a built-in Python function. You don't have to import any new packages to run print. And so for the changes that we made, creating weight and pound in patient ID, we can run this and we'll get 132.0 and then inflame underscore 001 for those values. And then similar to how we did print hello world, it doesn't display the function itself, it just displays what's in between the parentheses. So for these, when we're wanting to print the variable, it just prints the value of that variable and not the variable name itself. And so for back when we were doing lowercase weight and uppercase weight, I added in those strings to kind of tell us which value we were printing. So we don't have to necessarily look at the code, and we can just look at the output to see what that variable name was. And so print will actually take in multiple a mix of variables and strings in plain text, or even like whatever you want to put in that plain text string in the middle, as long as they're separated by commas. So for example, when we run this, it'll print the patient ID value, weight in kilograms, and then the value of weight in kilograms here. And as you can see with that print statement and the output that we're expecting, we don't see those commas. This is just to make sure that the separate values that are going into print are outputting correctly.
So if you wanted to have commas in that statement, you never put them inside quotations, right?
Yes. So for example, we can do like this, where we add the commas before and after the single quote, click run, and now we have those commas in the print statement. So print can do a bunch of different, print can have additional functions inside, as long as the function has, well, I mean, the function doesn't necessarily have to have an output, but for example, type has an output where it'll print out the exact data type of the value of the variable that's put inside of those parentheses. So 60.3 is our floating point, and then patient ID, as we remember before, was a string value. And so when we run this, and you already see the output here, but when we run this, we get the same output as before, where the float is 60.3, that's the data type for that, and then string is the patient ID. So what we can do is we can put weight here, the lowercase, and the data type for that was a whole number. So we'll get integer, or int for short. Okay, so yeah, print can do a lot of things. It can print out function output, it can print out a mix of strings and variables, and it can also print out the it can also print out calculations. So when we run this, we'll automatically get what weight in kilograms is. When we multiply it by 2.2, we'll forget our weight in pounds. And so this is a way of doing that calculation without saving it to a variable, which is sometimes helpful if you don't want to change or add to any variables and you just want to see what that output looks like in terms of like testing. And yeah. So if you look here, I say the expected output in weight in pounds is supposed to be 132.66, right? But the weight in pounds here is 132.0. So what we want to do is we want to make sure that the expected output that we're looking at is correct. So if we check what our weight in kilograms is, it's 60.0 as opposed to 60.3. So that's another way of problem solving, and we'll get into more of the debugging and testing our for errors later on. But using the print function is super helpful when you're running into errors, just to check what your expected values are supposed to be. And then also helpful for comments so that when you come back, you're like, oh, this is what I'm supposed to be expecting and this is what's happening instead. And then you mentioned before, when we're running code, if it changes the value as we're going through, if we set it equal to a new thing. So weight in kilograms, we want to set it to 65.0. And we run this, and now the weight in kilograms is now 65 as opposed to previously 60. Okay, so that's all for print functions. It's a super robust function. I'll stay on there for a bit. It's a super robust function. It can do a lot of things. And it's super helpful for getting output when you're running, say, a really long set of code and you want to know what's happening at each step. Or if you're just double checking and making sure what you're doing in the code. And another thing that's very helpful, that is a built-in function, is a help function. And what it does is it tells you about different functions. So you can put the name of a function in between the parentheses after help to kind of determine what is supposed to be happening. So that's this, what's supposed to be happening for this function. And then optional keyword arguments. So what could possibly go in here? So those are optional keyword arguments that can sometimes go in here, but these are what is, this here is what value is going to be printed out. And then these are automatically defined values that are in there that we don't have to define ourselves, but if we want to change what that is, we can. So for example, we had a question about if we wanted to print out the commas, we can either put that in the print function itself in the string, or this is the separator between all the different values. And instead of a space, we can say sep equals single quotation marks, comma. So we can actually try that out really quickly. So print weight kilograms, comma, weight underscore pound. And then set equals the pounds. So. When I run this code, I'll get the weight in kilograms as it currently is now 65.0 and the weight in pounds, which is 132.0. And then that separator is a comma now instead of a space. And we can change this to whatever we want. So if we wanted to separate it with an A or an underscore, you can have an A or an underscore. And this works for if we have multiple values as well. So, variables. So we have 65 underscore 132 underscore variables. So that's as many different values that you want to put in print, and then that's like what will be separated. So if we take this line out, then they'll be separated by space again.
Does the set could always have to be at the end? Or could it be anywhere?
No, the set can be wherever, as long as it's set within this, I believe. Let's see. Set equals. Okay. Well, you learn something new every day. So set always has to follow the value. Oh my dear. Okay, all right. Crisis averted for hopefully the rest of the day. Okay, so that's good to know. So when you're looking at these help functions, it'll determine the order that you need to have things in. Typically you'll have the value first, or whatever this is, what is said here, because that's like your non-optional values or non-optional arguments that you put in a function. And then these are built-in automatically set, and then these are our additional optional values. Yeah. Any questions about print or help? That was print, but let's.
So that
okay.
help will tell you what you currently have things set as.
Help will explain what a function does. So you can just type in, you'll see functions all throughout that will always have that parentheses, the open and close parentheses next to them. And if you don't know what that does, you can either Google it, or there's a way to look at it inside the Jupyter notebook so that you don't have to leave that environment. I'm trying to see if there's another, I guess we can do help on help. Okay. So this is something that was written for the help function, but mostly you'll get something that's a little more readable. Another function. Oh, type. So we saw type, and type is a function that'll tell you what the type of the actual variable or value within that open parentheses, close parentheses. So if we run this, it gives me beautiful. So it gives me a lot of different functions that can be attached to this. So help is supposed to be helpful in terms of a simplified version of what print looks like, to say this is what is an expected value of it. These are the values that you're automatically getting in there, and then these are optional keyword values, arguments that you can add in later on, if that makes sense. Questions on it? Does that help? No, not really. Okay. So just to reiterate that point again, variables can act as sticky notes as you go through to kind of timestamp, at this point in time, weight in pounds, 2.2 times the weight in kilograms, as weight in kilograms is set there. So if we run this, weight in kilograms is 65, and in pounds, when you do that calculation, is 143.0. But if we change the weight in kilograms over here to 100, weight in pounds is still the same because we didn't re-establish weight in pounds again. So it's another error checking you can make sure, if you're changing your values in different places, that you're still doing that calculation and you're getting the expected value that you're looking for. So this is something that we can all do together, because we'll go through line by line to kind of talk about what each value is. So for that first line, I guess like line number 3, mass equals 47.5. After we run this line, mass equals what? That's right, 47.5. And age is? So for line 3, since we're only setting mass, age is nothing. Age does not exist, right? So in that first, like if we just ran this first line without anything else going in, age does not exist. So then when we run this line, after we run line 3, mass is?
7.5.
Right, and age is? Perfect. So, so last 2 lines, mass equals mass times 2.0. So then mass is? Right. And then age is? Right. So age doesn't change if we change the value of mass. And then lastly, mass, if we do age equals age minus 20, age changes to 102, and then mass is still the same. So if we were to run this code, we get no output, but it's again, just to check your understanding to make sure that like as we're executing different lines, things are changing and some things are not changing as we go through. So what questions do we have on variables before we move on to list? Okay. So we've gone through what integers are, what floating point numbers are, and then what strings are. So another data type that we have in Python is list. So lists can be multiple different values, but you'll see them as opposed to just the variables where we're setting the numbers with decimals, without decimals, and then the strings with either single quotation marks or double quotation marks. Your lists are going to be denoted with square brackets and then commas in between. So for example, these are 2 lists. One is for temperature readings and one is for time. And you can kind of denote them as you will. For our example, we're using 24-hour time because it's easier than storing them as strings where we would have the colon in between. So what we can do is make those 2 lists of the same size, and we're tracking basically like both of those variables, but like as a whole across multiple different times. So we can do this also. I mean, for example, we can do this if we're tracking humidity at different time points throughout like 7 hours. And what you can do is you can set both of the lists, the humidity list and the time list, in the same way that we've done the temperature readings and time. So. Yeah.
Question online, do all elements in the list have to be at the same type?
They do not, no. And we'll talk about that a little bit later. But no, all list items don't have to be of the same type. So you can combine all of the different ones that we've talked about so far and put them all in a list as long as they have the square brackets and then commas separating in between. All right. So, so our humidity. Brackets. And then 35. You'll also note on here for humidity, you can have multiple, you have multiples of the same number and the same values, and it will not, erase any of them. All right. So we can type this in, but we want to make sure that we run it so that way we can utilize humidity and time for the capital T for later on exercises. So before we had the weight in kilograms and the weight in pounds, and we were denoting those to make sure that we knew what the units were for each of those weights as we entered them. For this example, we had temperature reading and time as separate lists up here before our exercise. And so now that we're setting time below, if we set it to the same name, we'll overwrite the previous time, which might make up for some issues later on. So when you're naming your variables, make sure that you're coming back to them and knowing exactly what you're using. You could, there's no rule against naming them X, Y, and Z, but it's very hard to come back and figure out what is X, Y, and Z when you could just have it as the variable name itself. To make sure that we don't lose this, I'll run this code. And yeah, okay. And then does everyone's list look like that? Oh, close. I did read my time list.
And I assume those commas are or the spaces after the commas are. If you didn't put commas in, or if you didn't put spaces in after the commas, it would get mad.
No, actually, so you can completely remove those spaces.
Okay.
Those are mostly for readability's sake.
Okay. I didn't want to experiment and then have to redo everything.
Oh, yeah, well, I mean, half of coding is experimenting and seeing what breaks and what it's experiment.
I mean,
but it's
all the time, yes.
Yeah.
Well, I'm in the middle of trying to pay attention.
Right, yeah, so actually, if we run this, it won't give you any errors, that's mostly just for readability's sake, and that's a good question, because sometimes the spaces and the tabs matter and other times doesn't, so. Great ad, all right, so, so when we want to view the values in a list, it's the same way that we print the values for any sort of variable. We can print them just as is, so the whole list, we would just write comma and then the list variable name. And we get an error. So our error is the time is not defined. And this is very low for you guys, probably. Okay, so the error is time is not defined. So now we should go back to where we supposedly define time, and check what happened. So, so you saw that like when I ran the humidity section, the in line is 42, right? And so here I defined time, but my in line is 5. And this is maybe, and this is definitely from the last time that I saved this and not during this run. So when you're running things in Jupyter Notebooks, whatever the session that you currently have is good, it's going to track all of those outputs from that particular run. So if you run it previously in a different session, and you exit out the notebook and you come back, like completely shut down the notebook and come back, it won't retain any of those values that you've entered before. And so that's why, again, comments, and then also making sure and double checking when we've run things. So we want to define time. We run this again, and we have 44 now. And we'll scroll all the way down and run this again. And now we have no errors, time and temperature readings are both set and defined. You'll also note that I didn't define time or temperature readings because those were both defined in the same block, but it only gave me the error. I can't find the time list, right? So that means that the first line that it hit, it gave an error, and that's the only error that you will see because it has not gotten to the rest of the thing. We're doing a lot of like error checking and debugging, so once we get to that section, just remember this. So there's two different ways of printing values in a list. This is the first one that we've already learned with print. And then the other way that you can do is you can loop through the individual items in your list using indexing, which we'll talk about briefly after. And then in session 2 with Jose, we'll also talk about for loops as well. So, because sometimes you only want the first temperature reading, or you only want the last timestamp that you got, and sometimes you don't necessarily need the whole list. In terms of like these brackets, there are ways of printing it without these brackets and commas. So before we jump into indexing, I would print the items in both the humidity list that we did before and the time list, and then whatever you named your time humidity list should be the one that prints out here. And we'll have Paul, Jose, and Alex be on the lookout for any questions, and then you can also ask me.
Question from online.
Okay.
Is it possible to run the entire notebook? Like, is there a button you can select to run the entire notebook?
Yes. So, so the question from online is there a way to run the entire notebook? And there is. So what you can do is you can click cell and then click run all, and it runs all of the cells in the notebook all at once. There's also restart and run all to make sure that everything runs in the order that you meant it to run in terms of sequentially. There's also a restart and clear output, which I probably should have done before the session, so that way we're not having any errors. But you know, we learn as we go, and like, what is coding if not to correct errors? How are we doing? Thumbs up if you're done with the exercise. Right, okay, looking good. All right, so, so just like we did before for printing the variables, we can just type in the name of the list, humidity and time humidity. Well, for me, time humidity, whatever you named your time list, and these are the outputs that we get. So square brackets and commas in between the values. So you notice that there's a bunch of different, well, mostly different values in each of these lists, and the number of items in these lists are the same because we're tracking the same. These lists are associated with each other. So, so this humidity list has 1, 2, 3, 4, 5, 6, 7 values in it, right? And we want to find, we want to pull the third value of the list. When it comes to Python, when you're numbering your list in terms of like an ingredients list or a grocery list, that kind of stuff, the list will start with 0, right? So that's just Some programming languages start at 1 when they're numbering lists. Other programming languages will start at 0. Python is one of those that starts at 0. So that means this one is the 0th. So if it's the first element, then it starts at index 0. The index will, I keep saying index, but index is to determine like what number item in the list, right? And so we can kind of denote that by asking for the index of the list here, or like what value we want in here, but this is based on that 0th element start. So if I want the third temperature recorded on temperature readings, I would need to set the index to be 2. It's always going to be 1 minus the value that you want. So third temperature 3 minus 1 is going to be 2. So let's move. That's not the temperature reading. So copy this one here. We'll add a block here and paste that. So that way you can see what the sensor readings are, and then just double check my work. That third value is 23.2. And so if we do index 2, third temperature, we'll get 23.2. And I put it here too. So smart. All right. So yeah, so we can do that. So for example, if we wanted the second value, we would put which index?
1.
1. So 24.9, oops, is going to be that second number, right? So, so this is helpful when we want to print out one value. This will be more helpful as we're going through loops later on, and we can print out every single number of that list individually. But what if we know the number that we want and we don't know where it is in the list? There's a function for that. So the function index will actually find that value within the list. So we'll take this out, print temperature readings again, and we'll see all of those values. And you can see here that 22.1 is that second to last value here. But I don't want to count this way, and I don't want to have to find out how many values are in here. So like, for example, this is a little bit trivial with this example because there are only 5 values in this list. But if you have a list that has hundreds or thousands, like you're not counting that. No one's counting that. So we're not counting it manually. And so if we just want to find out where this value is, we can do the list name and then dot index, which is the function, and then the value that we want to find within the list, and it will return the index of that value. So to make things simple, as opposed to setting temperature readings.index 22.1 to a variable and then printing it, we'll just print all of that value when we run that. So index they give is 3. So this doesn't mean that this is the third value in the list. This means that when we start from 0, 0, 1, 2, 3, then we'll get that 22.1. So this gives us the exact index that we can do print temperature and typing all of it. So if you have a long list name like we do here, and you're gonna maybe encounter some errors typing it out like I have, you can start typing it and then you can click tab, maybe. Sometimes it does it multiple times. Sometimes you can click tab and it'll give you the rest of that thing, so you don't have to type it all the way over. So temperature readings is the list, and we want to see index 3 just to double check our work. And we'll run this, and we get 22.1 is the value. Yes.
If you have multiple values that are the same.
Right.
The only times the first.
Let's check. So we talked about that with humidity, right? Humidity has 35 multiple times. So we'll type in humidity and 35. So this, and then we'll comment this out because we don't want it to print anything. Yeah, so it'll only give you the first value that it runs into. as opposed to all of them. There is a separate function, I believe, but I don't recall the name as of this moment, that will pull all of the values or all of the indices of that particular list that like have that number. Yes.
So as of right now, these two separate lists stand independent from each other, so it doesn't associate 35 with the 1200 reading or 33.
Right.
Okay.
Yeah. So yeah, as it stands right now, we just have that like internal association as opposed to like in Python itself. Yeah. Any questions? Okay. So, let's see. So these are this is to go over the exercises for the humidity list. Because what we can do, is once we have the index, since we know the indices match for both the humidity level and the time for the humidity tracking, we can just set that same index for that other list to find out that associated time. If that makes sense. So, yeah, so I think last, maybe second to last exercise, before we go to break, to just double check and see how the humidity list is doing and all of those indices for practice. Yes.
Question from online.
Mhm.
What happens if you try to use index on a value that's not in the list?
Let's try. So humidity index level, I don't even know what 100 looks like. When we run this, we'll get an error that says 100 is not in the list. So this will stop your code from running if you encounter this error, but at least you know that it's not in the list. So. All right, thumbs up if you're done with the exercise. Okay, I'll hold off a little bit longer. And our next concept is something that we already technically asked through an online question, where lists can contain any data type. So you can mix and match and put whatever you want in there. So this can be data for like a student that can be mixed into, or just data for grades or a bunch of different things. The world is your oyster. All right. Yes, do you have a question or troubleshooting? Okay. Thumbs up for done with the exercise. Okay. More. All right, so we wanted to get the fourth item of the humidity reading list. Our format's going to be humidity square brackets. And since indexes start at 0 and not 1, our fourth item is going to be 3. We want to find the index for humidity level 30 and humidity level 36. We'll just slot those into humidity dot index with the parentheses here, so 30 and 36. So you run that. Similar to what we had before, if 30 is not in the list, it won't print it, and then it'll stop all the code that's happening. So if we comment this out with the pound sign, like we do for comments, and run this again, we'll get humidity, the fourth value, and the humidity list is 34. And then our humidity index for 36 is gonna be 2. That makes sense? Any questions? Okay. Yes. Question or troubleshoot? We have questions. I see.
So we got the
Oh.
error because there was no 30 for humidity.
Right.
I'm trying to figure out what my error was as I'm.
Yes.
So I didn't move on to the third line.
Right, yeah, so when you're doing that, make sure that you're reading the error that you're getting as well, so then be able to troubleshoot. Okay.
Yeah. First one.
Alright. So, so I'll move right along so that we can make our break. So lists contain any data type. These ones are just string and characters as opposed to like a mix and match of the values that we want. But this, again, like whatever values that you need in your list, you can include, depends on the list that you're making. So these, for example, have our string values, and either you're already going to see the quotation marks inside each value when you're printing the entire list. And that's how the dice rolls. And we'll run these just in case we need them for a later exercise. Okay. So, brief exercise, just to practice making shopping lists. So, you can make your shopping list, to buy these, items in your list. And you can use either single quotation marks or double quotation marks, and that's the same for, any string that you're doing, as long as the, first one matches the last one. So no mixing and matching, single quotation, double quotation, or the other way around. We'll get here. All right. So you could do this and get an error. Because it has no idea what those are. Could do this technically and not get an error, and it looks okay, but a print. Oh, I can't even. So could go crazy. Okay. So if we wanted to print the first index of this, because we put all of it in quotation marks, as opposed to each individual item, that first item is going to be all of them. Right, so make sure that when you're doing it, you're separating all the values. Into these. Then our first value is just apples.
So if you would have then put 1 while it's still under the single quotes, would have put apples. So 1 will give you an error because there's only one item in the list. Yeah. Can you have spaces in your variable names, or does it need to be? like
You
underscore?
do have spaces, so you can have spaces in your variable names, or else it'll be counted as two variables. Yeah. Okay. Any questions on string list, number list? No? Okay. All right, and I'll kind of run through this a little bit. So you can change one of the values in the list. If you, okay, so did we set this earlier? So we set this earlier, and if we didn't, it'll give us an error. If I wanted to change one of the values in the same way that we set a variable, we just set that list and then whatever the list item that we want to change to the new value that we wanted. So if we see here, this was originally C++, and if we change it, if we wanted the first value to change to C#, then we can do that, just like that. And we don't have to necessarily reset the whole list and type out all the different values again. So that's called mutability, which means that you can change those values at will, and you can change part of those values at will. Trying to think what are the ones that, so mutable data types are more like the variables that we were looking at in terms of the numbers, where we have to change the entire value as opposed to just like part of the value. So if we wanted instead to like add 0.5 to weight to make it 60.5, we can either do that addition, add 0.5, or if we want to completely reset it, we'd have to type in like weight equals 60.5 instead. And we'll rush over that exercise and we'll come back to it later. So just an example of containing multiple data types. We haven't necessarily gone through that, but we will go through Boolean types in session 2, where there's false and true, which is helpful for like being specific on like if we want false or true, as opposed to just zeros and ones. And as you can see, if we have single quotation marks or double quotation marks, they're both strings and they both default to single quotation marks in a list. So there's a bunch of different things that you can do with lists that I'll briefly go over before we jump into all of the other sessions that we do, and also before we jump into break. So we have already done how to change and manipulate one value in list. So you can add to the list and throw things at the end. If you don't want to change a value within the list, you can also insert and like add values at will to wherever you want in the list itself. And then there's removing and reordering items in the list. So we can go over those, or we can go through and practice what we need to with lists that we've already covered. So that way we're not trying to cram in like 20 minutes of information in 5 minutes, which will be very rough for both you and I. So, so in that case, we'll end off with creating a list containing multiple data types. And then we'll break. While we're doing the exercise, are there any questions from online about anything that we've covered in session 1? Okay. thumbs up if you finish the exercise. We're starting, okay. So for those that are already done, what list did you make?
I just did something similar. I used text numbers. I tried to use the percentage and realized that percentage shared out.
Yeah.
I did a quick like 26 minus 5 times 9. Produce
Yeah, so it can be a random collection of stuff. It doesn't necessarily have to, I think we made it relatively hard exercise to come up with an example that's relevant to work, but yeah, like I mentioned before that like student data might be something that combines both like strings and the different values in terms of like grades and like maybe like a student ID or something like that. So yeah. All right, well, we'll wrap up this session in a couple of minutes, and our next session starts at 10:40. Session is 10:45? Oh, 10:45. So we'll be back at 10. Yeah, so we'll wait a 15-minute break. Bathroom, get water, stretch. Something to note is that that same pop-up that I had on my screen that said restarting may have already popped up on your computer or may be popping up soon. So make sure that you use that so that you don't have to move computers. I don't know how long that restart will go, but just something to note. All right, well, we'll see you guys back at 10:45.
Next, there we go. I'll be your presenter for the next session. Okay, so before we get started, this session is gonna be mostly about loops. So how do we loop onto lists? And then how do we make logical choices? How can we do if statements to work out decisions through Python programming? Before we get into that, I do wanna say one more thing about lists before we get started. It is about how to add to lists, okay? So we went through how to make a list, right? And how the indexing works on the list. And here's one example of that. We're just gonna write book titles on a bookshelf. Physics, Python, chemistry, right? And I wanna add a book, but I don't wanna have to redefine my list. I just wanna be able to edit my list as I keep going, right? And for that, we use the function append, right? So I can write the name of that list and then go dot append. And then in parentheses, put whatever item I want to add to that list, right? And that'll be tallied as an extra item at the end of that list. You can go ahead and try this out with any of the lists that you have made. Go ahead and dot append what you need there. And you can go ahead and print it out at the end. In this case, I'm just gonna print out bookshelf. So you can see how that looks. Right? And we'll always add it at the end, right? There are ways to make it so you can append at different points, but the default is to append at the end of your list, okay? We'll be using the append function later, okay? So I just wanted to give you a heads up so you can see it here before we get into session 2. Now before we go in, any questions about lists, how to define one, how to add to one, how the indexing works, okay? All clear there? Okay, that's the indexing is very, very important going forward, okay? So. Now, we talked about that, we reviewed the basic facts of lists, right? So now we can talk about what we mean about how to loop, how to do for loops with this. So let me scroll down a bit more so that the print statements end up at the top, okay? Yeah, correct. So if you're in session 1 notebook, go back to your files directory and click on session 2 notebook, okay? Everybody there? My bad, just started there, okay? Good. Okay, so starting on session 2, you'll see that you have a list of odds numbers, right? It says odds 1, 3, 5, and 7. And I'm gonna print out my list. Okay, so I'll go odds 0, odds 1, odds 2, and odds 3. Now, please take a look here that I'm using the brackets, right, for those indexes. These are not parentheses, these are brackets 0 when we're gonna call that specific index, right? If I change to parentheses, it'll throw an error there, okay? Because I know this is something some people worked on when they were doing the printing beforehand, how the parentheses and the brackets interact. Okay, but if I run this odds 1, 3, 5, 7, it runs okay, right? It goes ahead and prints out 1, 3, 5, and 7. Now, if I add an extra number, if I add 9, let's say I add the next odds number on that, you can go ahead and do that on your side as well. You see that 9 is now printed. I have to create an extra statement and go ahead and say, please print out. I'm just gonna copy this statement right here and change the index to odds 4. Right? And this will give me 1, 3, 5, 7, and 9. Okay, but what is the problem with this? Let's say I have a list of 100, 200, 300 numbers, and I want to actually see and print out each value, right? I would have to write out each index, and I will make a mistake at some point, right? So how can we repeat an action without me having to write that action how many times I have on that list? The other problem with this is that if I remove a number, right? If I remove 7, I get 1, 3, and 5, and I keep this. We've run that code there, we'll get an error, right? Because they'll say that the last index odds 3 is out of that list, right? So it's not scalable. I can't edit once. I would have to make 2 edits every time I want to make a change to my list, okay, or to my collection of functions to go ahead and print out the list. So what we're gonna do now is actually write the evens, right? So I want you to write the even list, go 2, 4, 6, and 8, right? And we're gonna find a new way to print this out, right? So if I define the list even, I'm gonna write out 2, 4, 6, 8. Oh, I just made clear it all. There we go. Okay, there we go. So we have the even list, and to repeat one, we're gonna make a for loop. Okay, so I'm gonna say for, type it just like that, each value in my list of evens, and then you're gonna do a colon. Okay, so these colon is very important because it tells the Python that the next line on there is the action is gonna repeat, and it's gonna repeat it for every value in that even list. Okay, so after that, I just hit enter, and it's gonna tab it for me. Okay, it's gonna create this index. Everything inside the index is gonna be repeated by the for loop. Everything outside the indent is not gonna be repeated by the for loop. And we'll see multiple examples of how this plays out. Okay, so in this case, I write for value in even, and then I go ahead and print the value. Okay, and that is our completed for loop from top to finish. So once we run this, we get 2, 4, 6, and 8, right? Printed out. I can keep on adding numbers to even. I can take them out, and I don't have to change my for loop at all. I don't have to touch it, right? So I can keep repeating, and I can change the initial conditions without changing everything. A couple of observations here. It doesn't have to be for value. It can really be for anything, right? So I can write for I in even here, as long as I change the name inside the for loop, right? So as I said, print I, right? I can go ahead and say for X in even, for number in even, and really any variable name that I want to choose. So this name follows the same conventions as it does for any variable in Python. Right, so I can truly pick anything there. But we do have some like constraints, right? We like to pick things that make sense, right? We don't like to pick stuff that, like I could write for banana and even, but if I come back 2 months later and I try to read my code, I'm not gonna know what banana stands for. I know what number stands for, and value as well, okay? So that makes sense there. So that is how we write our for loop. And for most stuff, that is the general structure of how for loops go. For variable in a collection, in this case, in our list, colons at the end, actions underneath, okay? Now, what did I mean when I said that stuff after the indent? So if I go print I can go ahead and print something here. And that print will not happen in the loop. That print is outside the loop completely. Okay, so just pay attention to your indents. Don't use spaces, okay, because it can get confusing very quickly. Go ahead and use tabs or just let the enter do it for you, right? But the tab will give you the specific indent you need to make that clear for yourself and also for the program itself. So you don't get confused, particularly if you're doing fors inside of for loops. It can get pretty messy pretty quickly, okay? Any questions with for loops and how they're structured? Everybody could get the evens to work out and printed out those first 4 even numbers. Yeah, okay. Okay, so these next exercises are just really written there, so we'll discuss them, right? You can run them if you want, but hold off on running them for a minute so we can read them together. So in this one, I'm defining length as 0 and I'm defining 3 names, right? So I'm going for each value in names. What am I doing here? Length equals length plus 1. What is supposed to happen at the end of that for loop? What? It's gonna sum 1, right? But it will, how many times will it go through the for loop?
Once.
What is that?
Length of this use.
The length of the list, which is 3 numbers, three names, right? So every time it goes through the for loop, it's gonna sum 1. So at the ending, it's gonna say there are 3 names in this list. Because for each name, I went through that for loop again. Okay, we can go ahead and try and run that. Right, there are 3 names in this list, because that means it went 1 for Curry, right, and it went once, and now length is 1. It went 1 for Darwin, now it's 2, and 1 for Turing, and now it's 3 times, okay? So that's how the for loop repeats itself through it, and that means that the variable value is actually changing through that for loop, right? Even though value is just a placeholder, value changes each time we go through the for loop. The first time we went through, value was Curry, the second time it was Darwin, and the third time it was Turing. So that means I can do different things each time I walk through that for loop, so to speak. Okay, so we'll actually see this in this next one. So I'm gonna define a name, right? In this case, Rosalind, that's my name outside the for loop. And then I go for name in the list of the 3 names we had above, print the name, right? And then after the for loop, the name is, right? Because once we use a variable in a for loop, that variable does not disappear. Right? The last value it had in that for loop, it will remain. Okay, so actually, so if you go through this, it's gonna print out Curry, Darwin, Turing, and then at the end, you see, even if I'm outside the for loop, it's gonna print out my name is still Turing, because you didn't change me, variable still exists, right? Even if you print me outside the for loop after we're done. Does that make sense? Okay, so we'll see. Me, the name here, right? So we can actually change this statement here. So if I print. Go ahead, if I change this. To redefine it inside, what's gonna happen now? If I put the name equals Rosalind in the for loop. What happens if I run that code as it is right now? What is that?
It changes everything.
Yeah, it will print out Rosalind 3 times, right? And but if I put the name equals Rosalind after the print, right? I go ahead and put it after the print. It's still gonna print out the correct one, right? Because it's going to the print first and then change the name. Okay, so this is important for us to keep track of variables, and in practice, don't use a variable name inside a for loop and use it outside, right? Because that way we avoid the confusion that this creates, okay? We just, let's caveat that if you're reusing names, very clear about what you're using in a for loop and what you're using outside, okay? Yeah. Okay, so having said that, go ahead, we're gonna add a space here. Want you to create a list of groceries, go ahead and put 4 items there, and print them out. Go for each one of these, print them, and then count them. So do the same thing with it for length. So you're basically combining these 2 together. So you're trying to sum them up, and then you're trying to also print each one out. Okay, so I'll be working on that. I'll give you about 3 minutes there to just figure it out. Make a list of groceries. Okay, how we doing? Okay. We got there? Yeah, I'll walk you through. I did it on my side. This solution may not be exactly the same written down, but principles should hold, okay? So we have a grocery list. In this case, I did banana, oranges, and apples. I did length 0, right? So I can get a place to sum up what each time I go through my for loop. For each item in groceries, I'm gonna print out the name of that item, so I just go item here. And then I'm gonna go length plus equals length plus 1, right? So I sum 1 each time. And then at the end, I'm gonna print out how many groceries there are by saying print out the like. There we go. Alright. Okay. Makes sense there, right? You just combine the top 2 exercises into one place. Okay, so you can see you can add more than one thing in each for loop, right? And it's common practice to do so, to just if you want to repeat something in the same list, you go ahead and you'll combine it into one for loop. And it tends to work out pretty well. Okay, but just keep your stuff separate, your names and conventions that make sense. Okay. Any questions there? Makes sense? Good.
I left the length equals 0 out originally, and it came up with the duplication, or we have to basically said 8 items on my 4-item list. Is that
So were you reusing length from the above one? Because if you reran the top exercise already had length on. So you were just tagging onto the same variable that you already used. Yeah.
If you run it again, you'll see that it becomes 12.
Yeah.
And 16.
okay? I redefined
Any
it.
question by that?
What is the plus one?
Cause I'm summing one for each time I go through the for loop. So for each item, I do +1. Like if I wanted to, I could do +2 or +3. But it would end up being 6 or 9 groceries instead, right? So if I said, if I know that there is these 2 oranges, 2 apples and 2 bananas, I could do 2 + 2, right? And then it would sum it there, right? But then it's up to me to change the number. Yes,
How do you identify which statement is inside of the loop?
Yes.
Or outside the loop?
so the indentations,
But I want two print statements. One has an indents, one has no.
Yeah.
They have the same result.
what do you mean the same in here?
Yeah.
So this print statement is printing this, this, and this big print statement only prints out once. Right? Yeah, this top print statement prints out each item individually, because it went 3 times, and this print statement only prints out length once. Alright, if I put that print statement inside, actually, you'll see that will print the length after each one. So now that print statement is inside it, and you'll see when I run it, I'll get it 3 times in a row, right?
Yeah.
Okay. Any more questions? Yes,
Why do you put length equals 0?
here,
Length equals 0, why 0?
oh, because I need an empty variable to be able to sum into, right? If I already start with 1, then when I sum that 1 + 1, it'll give me that bananas is not the first item, it'll give me 2. Right? Because remember the indexes start at 7. Right?
Okay, learn something. Print has to be lowercase.
Yes, yeah, Rick cannot be able to. Any other questions? In there? Okay, makes sense. Okay, so that was for loops, an introduction to for loops. And now we're gonna be looking at a built-in function called range. Okay, so range is curious in the case that it can take from 1 to 3 input numbers. Okay, and we'll see what each one of these does. Okay, so range, we'll write it, go ahead and do it with me every time, write it up. Let these on purpose in blank so you can fill them out in. So we're gonna do, the first thing is range 5, okay? If I run. Okay, I'm just gonna go ahead and go print. I should still. Okay, range 5, my bad. Okay, I remember now. Okay, so for range 5, it's gonna say all the numbers from 0 to 5. And that's all whole numbers, so 0, 1, 2, 3, 4, okay? Now, the way we use this in a for loop is by saying for number in range. Go ahead and print that number. So range allows us to use it as a shortcut, so when we want to repeat actions and it doesn't matter what the list is. Okay, so let's say, for example, I want to compute a power of something. I want to multiply a number many times, and we'll actually do that exercise later today. I can use range instead of inventing a list of stuff, right? Instead of trying to put all the numbers in the list, Python builds it in for me. So go ahead, so if you're at for number in range 5, print out number. Okay, so we're gonna see what that does there. It's gonna print out 0, 1, 2, 3, 4. Why doesn't it print out 5? Starts at 0, right? So it's gonna give you the first 5 numbers. As indexed by Python, right? So from 0 to 4. And I can change that number to anything and the range will hold up, right? Now, range also allows me to put a beginning number and an ending number. Right, so I can go from 5 to 9. I can run that too. I get 5, 6, 7, and 8. Okay, so now we see that the ending number is never included in range. Right, if I go range with only a single input number, I don't get that last number. If I put it as the ending number, it also doesn't include the last number. Okay, any questions there? All good. And then range allows us to actually add a third number, which is similar to how we jump, right? So if I go 5 to 9, but jump by 2s, it means that it will start at 5 and will sum 2. So 5, 7, and it will jump again, right? So let me go ahead and run it. 5 and 7, right? Because I cannot print out 9 because it can't be the ending number at all. Okay, so I can go ahead and change it. I can go 5 and 12 instead, and you'll see a couple more numbers up here. Well, let's keep on counting. Right, 5, 7, 9, 11. Okay, so, and I can actually change that last number to whatever I want. I can make it count by threes, by 15, whatever I want, right? So range allows us a lot of flexibility when creating lists of numbers built in without having us to make this ourselves. Okay, Python allows us to do this built in. Okay. Now, the exercise I want to do now is that you're gonna, using the same syntax you have here, go ahead and try to print out the first 3 odd numbers. Okay, without making a list, we're just using range. Print out the first 3 odd numbers. Okay. Thumbs up if you got it. None there. Okay. 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 Good. Okay. Sounds good. Most of you got there. Okay, now I want you to edit it again, and for the next, actually, let me write that one out first. So we said the first 3 odd numbers, so I'm gonna go from 1. Make it count 6. Right, 1, 3, and 5, right? Makes sense. Okay. Okay. Now make it the first 3 multiples of 5. I want 5, 10, and 15. Okay, just to make you practice again with changing the index. Okay.
What's changed, you know?
What is that? 5, 10, and 15. Okay. Remember, the last number is never included in the. So you need to overshoot by 1 about a little bit. Thumbs up if you got that one, the multiples of 5 one, okay? Good, okay, so let me write it in, 5. Right, but here, instead of 15, what number do I need to put here? 16, right? It would be the same if I put in 17 or 18, right? Because it wouldn't be able to make that next jump of 5. But if we go past 21, then we get 20, right? So if I go 16 and then jump by 5 instead, we get, okay, 5, 10, and 15. Okay, so I think we got a pretty good handle on how range works. Okay, so now we're gonna move into this exercise here, into understanding loops. Okay, so actually I gave you the answer for this one. I don't know why I highlighted it, but it was just, I think I just left it over. But basically, this is for strings, so strings can also serve as a way to make a loop, right? So I can say, if I have a word, in this case, I have oxygen. For each letter in this word, go ahead and print the letter, right? And in this case, my for loop is gonna go through the amount of letters in oxygen, right? Or the amount of characters inside my string, okay? Now, this is where it gets really interesting, is what is a character, right? Do we consider spaces inside the string characters? And this is the part I want you to experiment on. I'm not gonna tell you the answer to this. So go ahead and copy paste this in, the word equals oxygen 1. And see what happens if you put a space after oxygen or before oxygen, right? Try adding or taking away a letter. And let me know what you see there, particularly with the spaces, okay? So let me just click in and copy this out. Remember, double click to be able to see the markdown, so you can copy it. Go. And remember to fix the indents, right? That print statement needs to be right. I'm gonna run it just exactly as it is, word equals oxygen for letter and word print letter, okay? Now, try to put a space in there somewhere, see how that changes the output of what you get. Any observations you wanna share? Adding space?
In space.
In the space, right? So that means it's running an extra time. If I add a space, it does count as a character, and instead of 6 times going through the loop, and now go a 7th time wherever I put that space, be it at the ending, the middle, or the beginning. Right? It doesn't really matter as long as it's inside that string. Okay, so go ahead and run it here. There we go. So that means that this counts as a character, right? It counts as the space character. Right? The same thing as it would be a dash or a comma or a period. Okay, so just keep that in mind, particularly when using strings as what you're looping through, that spaces do count as characters, right? Okay, so any questions there with that one? Okay, so let's keep practicing, okay? Because that is all coding is, it's just making mistakes over and over until you make little ones, okay? So for this one, I actually want to work on this, how to make that exponentiation, how to multiply a number multiple times. Okay, so Python has a built-in, you can go 5 to the power of 3 by using double asterisk, right? Using double stars, that tells it 5 to the 3, it prints out 125. But I want you to make a for loop that does it. A for loop that multiplies 5 3 times. Okay, go ahead. Try and see. I'll write out the beginning part of it, the for loop itself. Okay, and you just have to loop through something 3 times, get it to go up there. Okay. You can use range, you can use a list of values, up to you. Okay, there are multiple solutions to this, so do whatever feels more comfortable. Also, to multiply is 1 star. I think you'll need it for this. Okay, I don't want you summing all the way to 125, and we'll be here tomorrow. Okay. Thumbs up if you got it, you got a solution down for this. Alright. I'll give you 2 more minutes before I spoil the fun and interrupt. Okay, anybody got it down? Yeah? No? Halfway, okay. Yeah, so here I'm gonna write the one I was doing, so. I'm gonna define a variable as result, where I wanna store my result in there, I'm gonna make it 1, okay? For I in the range, I'm gonna make that range 2, because I want it to go 0, 1. Actually, I wanna make that range 3, right? I want it to go 0, 1, and 2, I wanna go through it 3 times, and then multiply times 5. Right? I'm gonna run this, should work out. Right, because it went through the loop once. And multiply times 5, goes through the loop again, multiplies 1 more time, goes through the loop again, multiplies a 3rd time. Right? Does that make sense there? Now, this is different in all other examples. Why? What's happening with the I here? There's a difference between this and what we did before. What is that?
Is it because there's no assigned range? I mean, like data set?
No, there is an assigned one. It's the range 3. I'm just not using I in my for loop. Right? That's the only difference. Before this, we've used I every time. We've used I or the value, whatever it is, print I or print the value. In this case, I just used it to go through the for loop. I didn't need to print it out. Right? Because if I wanted to, I could go ahead and print I here. Right? And you see that each time I'm going through it, it just goes 0, 1, and 2. But each time I'm just multiplying that result 1 out. Okay? Does that make sense there? I just made everybody very confused about for loops. I'll take it about half and half. Okay, yeah.
Use this instead of just doing print by the tower. Oh, yeah.
You wouldn't. This is a nice example to learn how to use for loops. We have to make up exercises as we go, right? So in reality, most times I would just use this. I would go 5 to the power of 3, I'll get 125. right? And we'll use for loops for more complicated stuff that we want to use. But for sake of an example that you can visualize and that we've done many times by hand, right? We've done this before in math class, so this turns out to be a nice example to use in coding as well. But yeah,
Can you help me explain what I did? Cause I got the same result, but I
Okay.
did different. I did, for number in range 6.
Right.
Print number, double asterisk 3, and it listed 0, 1, 8, 27, 64, and then it came to the final answer of 125.
yeah, so what you did was you went through the range and then you exponentiated each one. So you
Okay.
exponentiated 1, you did 2 to the 3, 3 to the 3, 4 to the 3, and then finally 5 to the 3. Alright, so you went through each value and took it to the power of 3.
Okay.
Right? Yeah, so that's another example. You can, and there's many ways to get to the end result when you're actually coding through stuff, okay? Okay, now. For this next one, I'm actually not gonna do this one, even because I think this is some of the one you're just summing. But we're gonna go straight to decisions. Okay, so before I dive into decisions, any questions with for loops? Any questions with the for loop structure, for value in a list? How do we work with that? And the colons at the end? No? Wait a second there. Is any other questions pop up? No, okay, sounds good. Now, for this next part, we'll be talking about how to make decisions, right? So till now, we've told mostly the program what to do and it prints it out. Or it sums what needs to be done, and it has mostly been a calculator up to this point, right? Or a more efficient calculator, because you can also do stuff with strings and words and other stuff, right? But what happens if two things? I want to be able to interact with the user, right? And I also want to be able to make the computer take decisions without me having to take every decision that I write. Okay. Here we need two different functions, and they're actually written down for you. The first one is input, right? Input allows you to take input from a user in Python. So in this case, if I go the input function, once you run it there, you'll see that it will ask you enter a number here. I'll turn that beautiful thing to insert a value there, right? Now there's a caveat with that. When you input a number, its default setting is that it's a string, right? We cannot sum strings with other strings, right? We cannot sum strings with numbers, is what I meant to say. All right, so even if I put a number here, which in this case can be 65 or 700, the input is still gonna be a string. So I need to change that input to something I can use, right? And the way you change it is by going int, right? This int right here tells it, hey, change that string to an integer. So I can sum with it, I can divide it, I can do calculations with it, okay? Normally, if not, it's gonna give me a type error. Okay, so these are the two functions we need together, and these are built in, so you can use them out of the box with any Python. Right, and you can go ahead and once I click on 65 and go enter, it will give me what I'm looking for, which is print out string and number. So in this case, this 65 is a string, this 65 is actually an integer. They look exactly the same, but if I try to sum them with something else, one will work, the other one won't. Okay? Everybody clear there with what input and int does? We'll be using input a bit. So just for input, just this text is gonna be your, what's it called, your prompt text, right? Enter a number here, and then you're gonna actually input the number that you took. Okay, and then you save it to the variable. In this case, I chose the variable input. You can save it to any variable you want. You can save it to the variable number and then use that afterwards, et cetera, et cetera. Right, and we'll be combining this with what we call Boolean values. Now, Boolean is the fourth type of data. Right, we have, what are the first three? Okay, integers, strings, floats, right? Now we go to Booleans. Booleans, there's only two. It's either true or it's false, right? And these are how we make logical operations in Python. We have, so in this case, these are multiple expressions. So if you actually run these, you'll get a printed statement from this, but you get what the Boolean value is for each of them, right? So if I say true does two equal two? That's when we put two equals in front of it, that means is two equal to two, in this case, that is true, right? Is 50 divided by 2 less than 24, is 25 less than 24, it is not, so that is a false value, right? Is true equal to 0, that's a false, because true is 1. Okay, in the language of Python, true is 1, false is 0, always, okay? Yeah, and those are the print statements there. And this allows you to make decisions, this allows you to compare values, and this allows you to create more complicated decision-making opportunities, right? And we combine this with if statements, right? And the general idea of an if statement is that if a condition is true, please execute said action, right? If I finish this Netflix series, please let me turn on the TV and not put on it, okay? So the idea is that I can determine what that condition is, so I don't have to verify the condition every time I write it. Okay, and we'll actually see some examples of how if statements can be run. Okay, so before we go to this, we can talk about symbols, right? So you just saw that I said equal means it said equal to, right? And the other ones we recognize from our typical algebra class, greater than, less than, greater than or equal to, less than or equal to. And then this one may be new, which is exclamation mark equal means does not equal, right? This is the new one, the equal to and does not equal. Those are the new symbols there. The rest of them we've seen before, right? You're familiar with those, so we'll be using these to compare numbers in our code. Any questions till now? Okay, true, false, yes.
So if you saw before, the true is with a capital T and the false is a capital F, and that's the word.
Yes.
It's lowercase, then it's not a boolean.
Yes. Please use capital F and capital T's. It's necessary for it to identify. Same thing we discovered with the function names. You need to be able to keep them in the same way. Okay? So that's how those work. Okay. So now let's actually ask. So I actually didn't run this code, so let me write it up. So actually write this one with me. So I'm gonna say if 5 is greater than 3. Okay. 5 is greater than 3. Print out. If 5 is greater than 3, no parentheses there, print out B. Okay, and this should print out B, right? There we go. So that's how we write a very simple if statement, right? If 5 is greater than 3, you can go ahead and change the numbers. If 2 equals 2, let me write that one up. Actually, I can go if 5 equals 3. What should this print out? Nothing, right? That's a false statement. The if should not execute, we should just skip over it, right? So that is, huh?
The speed print speed.
Just a letter. Yeah, no meaning to be. I just want something to print out just so we know it's running. So if I say if 5 is equal to 3, print B, it should not print anything, right? We get 0 output, it just glosses over like it doesn't exist, right? But it did run the code, it just found that it was false, okay? And we can do this with all the other symbols, right? So this is how the if runs, okay? Now, actually, we'll do this one, right? So. Any questions there before we move on to integrating input with it? No. Okay. So in this one that we have here, right, we have an input, right? Enter the number here in this case. Hang on, Jake. It's not calling. What happened? Remember here. Okay, if I take error input out. Did I miss out on something?
This is something that, you might have run into if you got this error also when you're doing for loops for range. So if you use input and or range as a variable name, then it overwrites the function and now it won't do, what you want it to do. So, to correct this error, what you want to do is click kernel and then,
First change that and then restart.
Yeah.
Yes.
Okay.
Change the block that said input equals input, and go ahead and change the input variables out. Because it means we overrode what input used to stand. And then go ahead and click kernel and restart and clear all output. My bad for that one, just wrote it in. Yeah, and it's gonna give you this big button right here, go ahead and restart it. You should be good. Okay,
well, if you
there we go.
You say restart your output.
Yep, go ahead and restart and clear output there. I'll give you a minute to get it, my bad.
if you want to save your output, you can also do kernel just, restart.
Yeah.
And your output will stay the same.
Got you do that again, change these right here that said, that used to say input. Right under making decisions and go ahead and go to kernel and restart and clear the output on the kernel. Restart. Restart.
So the kernel restarts.
Okay.
So
Now you should be able to rerun the one that said, the one that after the B example, you should be able to run that one again and get an actual input box there. Let me know if that works for everybody, that input box. Thank you. Also here, put any number. I don't really mind which, just put a number that we'll use for the future exercises here. So, I mean, trying number, yes,
The only accepts integer.
yes, only integer numbers. Right?
So every time the interactive box only accepts integer.
Yes, unless you define it as a float, like to accept floats numbers. Okay, all good there? We could be able to reuse input again, worked out, okay. Okay, so now we're actually gonna compare some stuff, so we're gonna go to this one right here that says after conditional statements don't have to include an else, right? This is what we just did, we had an if statement with no else condition. What does else mean? It means that if I don't do this, right? That's what the else means in the if construction. But in this case, there's no else, it's just an if statement by itself. So in this, what is this if statement trying to do? What is it, what are we trying to get to? Not a trick question, I promise. Yep, it's gonna tell you if the number is greater than 100 and it's gonna print it out, right? Very simple standard if we're not trying to get to anything, so once you run it there, it's gonna. Well, because I had already one running, of course I did. There we go, and now it's gonna ask me enter a number here, I wanna put the number 1. And I wanna put the number 25, right? Once I click enter. It shouldn't say anything if the number is less than 100, right? Because it just said if number is greater than 100, print out it. So in this case, 25, then nothing. If I rerun the program, right? And I write 123. Now I run it. All right, 123, click enter. I should get 123 is greater than 100, right? Now I added the before conditional and after conditional statement just so you know that it is actually running. Right, even if you put 25 and it verifies it, it will print something out because I added those print statements there. Right, if not, it would do what happened in the previous one, which was it glosses over it completely, okay? We're good there, but what the if does by itself, okay? Now, how do we combine this with other actions so we don't have to print it out together, right? So we're gonna make this out, we're actually gonna write this one together. We're gonna make an if else statements that prints out if the number is positive or negative. Okay? So first, we're gonna check it. We go if number is greater than 0. I'm gonna go ahead and print positive. Else. And I don't have to define a condition for else, right? In this case, this is kind of a bad example because it won't know what to do with 0. Right, we'll just group it with something else, but just bear with me for a minute there. Let's hope none of you are math majors or math professors. And then just go ahead and write negative on there, right? And you'll be able to enter a number there. Go ahead and enter a number there. If I enter 1, so go ahead and give me 1 is a positive number, right? Positive. If I enter -2, it should give me negative, right? So that's how we construct with an if and an else. Things to observe. We have if, the condition, and always the colon, right? And we have else in the colon. Else is not indented inside the if. Else goes on the same line as the if statement, right? So we have if, the actual action inside the if, and then else and the action inside the else. Okay, so that's how the indentations work there for if and else statements. Okay, make it a bit confusing. If you write the else inside, it may not know what to do, right? So please keep the if and the else on the same line and then indent whatever actions you're taking inside the else and the if. Okay? Everybody tracks it there? Yes? Okay. Now, write another one that says if the number is positive or the number is 0, right? So you need to double check if one of them is 0. So you'll be able to go number, does number equal 0? And then change that condition. Okay. So, now if number equals 0, print something, else print this number is not 0. Okay, I'm gonna give you about 2-3 minutes to work that one out. But the same structure, is changing the actual prompts of what you're printing out. Okay.
Two if statements, if and else and else.
You can combine, it's called the elif construction. We're not gonna give it today, but you can combine it with the elif. That's what it's called when you use. Yes. ELIF. Me change those prompts with you. If number equals 0, say number is 0. Else print. Nah, 0. Right? And then again, if I print out 0, tell me is 0, and then I'll check again. If it's 9, it should print out not 0, right? We're changing out the print statements. We all got that one? Yeah? No? Yes, yes. A couple heads down, okay. Pretty good. Okay, so that's how if and else statements work, right? And now. Well, actually. Yes, now we're gonna put it all together, okay? And it's actually an exercise that is meant to take a bit of your time, so you're gonna crack your head at this one. And I'll talk you through this one, okay? So we have a list of populations. We have a list of 4 numbers, which are made up populations of something. And I wanna change this, I wanna sort them out, right? If the populations are bigger than 600, they're large. Arbitrarily, that's what I'm deciding now, okay? And if they're smaller than 600, they're small. Yes, okay, so I just wanted to append these numbers to their respective lists. You'll end up with 2 in large and 2 in small, okay? But think how you can do this with an if statement and the dot append construction that we just learned, okay? We just, let me redo that dot append one. If you wanna append something to that large list, you go large. Write the whole name of the list. I don't know why I made the name so big, but you can go ahead and shorten it however you want. And click dot append and then whatever you actually wanna append, right? So using if and else statements, go ahead and sort them out into their respective lists. You should end up with one if, one condition, and two append statements. I'll give you 5 minutes to think about that. There. Don't worry about calculating the mean for this one. I just want you to sort them out based on 600, okay? So this actually gives you the structure of how it looks like. You should have it there. The next cell has the structure of how that for loop should look like. Should go for I in populations, if this, add what happens, in this case, append, right? So go ahead and try to append it to where it should be. If you have any questions, please raise your hand.
Trailers at like 600 is the average for the different. One folks, the way this works. Yeah, because, effectively with, yeah, I guess, instead of doing the, I was say average people the list. Or the. Yeah.
Sure, no, go ahead. I mean, we don't stop you.
Yeah, yeah.
Go ahead and write it. You don't have to do the average, you can just do 600. If it's bigger than 600, change it, if it's average, keep it there, you don't have to do. That's good that you did it with an E. Question. Yes. Oh, it's because I don't want the average. Which I. No. Okay, some of you did it with the average, great job, good job. Either way, it's fine, I just wanted you to try out the if statement, so. If you did either exercise with doing either sorting it by 600 or sorting it by the average, that's great. For the average, you just have to do an extra for loop to calculate what the average is and divide it by 4. So if you did that, good. Okay, but I'll write out the solution for if you did the 600, right? So. For I in populations, if I is greater than 600. Go ahead and append it to large populations. What am I gonna append here? Oh, okay. No, it's okay. I'm gonna append I, right?
Yeah.
Cause you're gonna go through each value and each value is out. Yeah.
So I mean, that's something that they like, there goes the third year thought. Again, it's small, but they're great percent. Yeah. And now you know that, so.
Sometimes it stays loaded the previous one. Okay, so going back to this, if I go large populations dot append, I go I, right? Because to that large populations list, I want to add that value, and then I write the next one. Which is small populations. And then now question. Go. Okay, and then I should print it out. And we're gonna be in error because there's no populations defined. I haven't run this yet. So we're gonna do this one. And do this one. And now we're gonna run it, and now we're gonna run it again. Right? Okay. Right, for I in populations, if I is bigger than 600, append to large, else append to small. Right, I should be able to get both lists here. Now, please see that before we did this, we created both lists, right? We created large and we created small. It's not possible to append to a list that doesn't exist, right? So we created empty lists here so that we could sort stuff into bins, right? It's like when you're sorting, you need bins to sort stuff into, right? So in this case, we created the 2 bins beforehand here, okay? And then try to redefine it later. So the same thing that we do when we do length equals 0 beforehand, we need a variable to either sum into or multiply into. Same thing when we try to sort different values and create a list there. Everybody understand how we did this one? How we sorted it out with the ifs and the appends? This is a slightly more complicated one, but the logic is the same, right? I'm doing an if statement with a condition and then an else afterwards, right? And the else is truly the catch-all, right? If something doesn't fall into the if, it will fall into the else. That will be executed. If I write an if by itself, it could gloss over. But if I write an if and an else, the else will always be executed by some condition, okay? That does not fall in the if. Just to make that very clear distinction between if and else, even though they come together, right? Yeah. Actually, we have about 8 minutes, so let's do another one of these, right? So let's add 2 more values to this list, whatever you want, right? And then change the number. Change that if number to more than 200 or more than 300. Go ahead and try to change it and work around it. I just want you to get comfortable reading the condition and changing it. Make it equal to something, make it less than or equal than, right? Try to use one of the other conditionals we've used. Okay, I'm gonna give you 2 minutes there just to play around with that one. And I think it's important for you to get comfortable reading that if statement there. Okay. I know we've crammed a lot in little time, so as much practice as we can get looking at the if statement, looking at the else, and looking at the conditions, the better, okay? If you think you have a good grasp on that, there's an exercise below it, that's this last exercise. You can take a stab at it if you want, in the next 8 minutes, it's a bit more complicated, trying to count stuff and strengths. But this is, we just keep playing around with the populations one. And if you have any questions, just please raise your hand, or you can just ask right now, in terms of ifs and also in terms of for loops, okay? Because I don't think we're gonna be talking about those going forward that much. So.
So that changes. You're defining the list here. And then you keep appending to lists that are already attached, so. Rerunning this resets the list, keeps appending. Yes, keeps appending to the same. By rerunning this tab one, they become empty again. Now we have about 4 minutes before we get out, so
Yeah, so.
last thing I wanted to add is, we went through for loops, we went through the if statements, okay? If you have any questions about these, let me know, please. We didn't do an exercise that combined both of them together, but for now, I think we went through both of them pretty well. The only thing I would say is we are taking a break from 12 to 1:30. You can leave your stuff here if you so decide. There's gonna be a person at front desk, so numbers like we know who's coming in here and out. You can leave the stuff here if you need to. And yeah, we'll stick around for a while after this. If you have any questions that you didn't want to raise in the lecture, that's fine, and we can go ahead and get that solved now, okay? Sounds good, and we'll see you on 1:30 for the next one. Yeah. Question over there?
Good afternoon, we're continuing with our Python Bootcamp. This session, we're gonna go into a little bit deeper concept. It's called functions. Now, you've already worked a little bit with function, but you didn't really quite know how to use them yourself. So first of all, we're gonna kind of show what are functions, why do you need them? And then we're gonna go into kind of exploring more how you can write your own functions. Now, there's a second part of this 3, and that's like errors and exceptions, because you all run into exceptions and errors, and you see this kind of crazy mumbo jumbo with arrows and numbers in there. We're going to have a short session after this to kind of show how to interpret those errors. But first, functions. Now, what are functions? You've probably already seen if you need to calculate a value, for example, this example, how do you calculate from Fahrenheit to Celsius? Now, it's a very straightforward kind of function. It's you take the temperature in Fahrenheit minus 32, and you multiply it by 5/9. So if you need to have multiple values, you can program it like this. The freezing point of water, 32 minus 32 times 5/9, which is this thing is same with the boiling point, 212. How much Celsius is that? And what's hot water in Alaska, which this. So if you want to run this, it gives you all the answers, 0, 100. Well, 16 is a little bit warm for Alaska. And as you can see, when you do a lot of these formulas, it's easy to make an error. In this case, the error is I swapped this around. So when you have to repeat a function of an expression, it's easy to make errors. So that's why functions come in. You define it once, and then you reuse that all the time, and it's a lot cleaner. Now, you've already seen functions before, and one of them is print. So print hello world, things like range, things like types, we've discussed them before. They're all built, what they call built-in functions. Now, what I noticed in the previous section, and I'm going to go through a little bit of rehash that's not in it here. So what we've seen with input is that people use input, and then this next time you use it, it gives an error. So I want to take a step back for first with variables. So what we've seen is like, for example, we have what was right. So I declare lists numbers and I print it. And then I say and Python will just accept it. It will first print a list, and at the same time, the next time it will print hello. Now the same thing you can actually by accident do with functions. So like I said, print is a built-in function, and this will print 5. Now you can do by accident. Print equals 5. Now what happens here is first you print the number 5, then you redefine the variable called print, and then the next time you try to print it, it will just give an error because you want to call an integer as a function. Scroll. Oh, is it? Yeah. So what happens is you print the number 5, you redefine the function print, and then you try to call an integer as a function, which gives an error. Int object is not callable. So this is kind of, you have to be careful with what variable names you use, because you think, well, no one is going to assign print a number. But I've seen in one of the things here where someone assigned range a number. And then if someone used to use range in a for loop, then suddenly you get an error. And you think, well, this code is right. For I in range 1 to 5, why does it give me an error? It's because range is redefined to an integer. And range is a very common word. I mean, it's very easy to use range as a variable. So when you kind of think about the names of your variable. Now, since I redefined print, Python is kind of a little bit of like, I have no clue what you want to do. So in this case, we just want to start from scratch. So print is like variable. Okay, so let's get back to functions. So in this section, we're going to look at a number of things. Function by itself doesn't do anything. You want to kind of influence it. If you look at the Fahrenheit to Celsius, you give it as an argument. You give the temperature in Fahrenheit. We're going to look at how we can return a value, and we're going to look at scope of variables. And I'll tell you a little bit about what's going on. So just like a for loop, just like an if, a function starts with def my function, and then you have the body that's indented. So you see that's def my function parameters, and then a semicolon. Semicolon is always that everything after that that's indented is part of that loop. It can be a loop, it can be a function, it can be an if. In this case, you define a function with the body for x in range, and then you have some kind of crazy, this is probably kind of sea temperature thing, a function. So let's go back to that example of the Fahrenheit to Celsius. So let's live code this. So we want to write a function called Fahrenheit to Celsius, which calculates according to that formula the Fahrenheit minus 32 times 5/9. So we're going to start with, like I said, we're going to define be good. And then as a parameter, it's going to be take this variable. It can be any variable name, but like it's always easy to kind of take something that's easy to remember, that's kind of clear. In this case, we want to convert from Fahrenheit to Celsius. That's why we. Now it's a function, so you call it. Jupyter Notebook automatically indents. If you're using a regular editor, you have to indent yourself. So return, I've not touched return yet, but we'll go back to there. So return, and then then at minus 32. And there you go. Now, sometimes you want to be very careful. In this case, it doesn't matter how it relates to all this divisions and integers, but now we run this, no error. Now you don't print anything, so you don't get any output either. But we could just easy test it. What, did I make an error? So since there we go. It's very easy to make a type error, and you get that. So 31 Celsius of Fahrenheit is 5 degrees, which was this morning. So if you wonder how cold it was this morning, it was 5 Celsius. Now, you can call this in other functions too. So if you want to just print the boiling point of water, you do freezing point of water, you call 5 to Celsius, 32. And then you print this, the same with boiling water, the temperature of boiling water is 212. And suddenly this is kind of a lot easier to read than this part in the front. Here you have to kind of, what does this do? What does minus 32 blah, blah, blah do? If you have a function, this makes it much easier to read. So the same thing, you can call other functions from your own function. So say we want to calculate the temperature in Kelvin. Kelvin is what physicists use a lot. Now, you can do this directly, but in this case, we already have the function. We want to go from Fahrenheit to Kelvin. So what we do is we first convert from Fahrenheit to Celsius, and then Celsius to Kelvin is easy because you just take Celsius plus 273 point something. So in this case, we have two functions, the Fahrenheit to Kelvin, which first calculates the temperature in Celsius, and then it calculates the temperature in Kelvin, and then it returns that. So if you want to do the boiling point of water, 212 is 100 degrees Celsius, is 373. Oh, and so you first have to define it, so that means that you have to run it. So I was one step ahead. So the boiling point of water in Kelvin is 373. Now, so do you have any questions about what functions are? What kind of questions do you have for me? So, like I said, you take an argument and you want to return something, you calculate a value. So I've already shown it a little bit without explaining what it is, but that we have the return statement. So the return statement, what it does, it says, here I stop, I return a value from this function. Now you can have most people will put a return at the end of the function, but you can also just put it in the middle. And I'll go over some examples for that. So, and a value can be more than just a number. In Python, you can return anything in the thing. So if I want to create a long list, I want to have an easy function to create a long list. Now there are other ways, but so I write this function that creates a list where it has a value and a length. So for example, if I want to create a list with 6 times the value 0.5, or a list with 5 times the value, the number 8, or I want to create a list with lists. So what I do, I create a function that has 2 arguments. It creates a new list. It goes over the loop. And it appends that value, and then it returns something. So if I run this, I get a list with 6 values, 0.5. This has 5 times A, and this is kind of a tricky one. It creates a list with 5 smaller lists in it. So this is to show you that a return value can give anything. It can return an integer, it can return a string, can return a boolean that you can use in an if, or it can even return a list. Now, like I said, return means it tells Python stop here and don't continue the function. Most of these functions that we had before, the return is always at the end. But we can also do a little bit smarter. So if I program an amplifier and it turns the knob, at one point it will stop, it will not continue. In that case, say volume goes from 1 to 10. If its current value is less than 10, we can increase it. If it's 10, we'll stop. We're not going to increase it because there's no volume 11 on our amplifier. So I get a function called increase volume. It gets the current volume. If it's smaller than 10, it'll say, sure, I'll return the new value, which is current value plus 1. But if it's 10 or larger, it will say, I'm not going to do it, and I'll return. So if you give the number 9, it will say, sure, it's fine. It will execute this, but will not continue with this statement. So that's very handy. You just say, if something, return, but don't continue. So if I say 8, it will say, sure, I'll give you the number 9. If it's 10, this test will fail and it will continue with the next line. So it's kind of a conditional flow, and we've seen it with the if else, and you can do the same thing with functions. You can stop a function, like if a value is, if a test is breached, then I can return, otherwise I'll continue. So in this case, increase from 8 to 9. It says, sure, the next volume is 9. Now you say, increases from 10, it will say, it will do this test, it will fail, so it will continue to the next one, it will print that it's too loud, and then we'll just return 10, just so that it will stay the same. Now, sometimes you don't really care if there's a return value or not, and then you just return nothing. Now, Python doesn't like returning nothing, so it will always return, but it will return a special case called none. None is like, there is no value. So in this case, I just say print a warning, and then I don't care what it returns. Now, if I be smart as, I just say return value equals this. Now there is no return value, so it's none. So Python just say. It will execute the function, it will not return anything, and then the return value is none. Now, why is this important? We'll show you in a later example that if you do a function where you have a test and you return a value, and then you continue, but you don't return anything, it will return none. And if you expect it to return something, you might run into error. Do any of you have questions regarding the return value of a function? So imagine how many lines would this function print now? Would it print 1, 2, or 3 lines of message? What do you think? So in print warning, it says print warning, return 1, print message. Will it return this message? Will it print this message? The answer is no. Python prints this text, it returns 1, and therefore it will not execute these 2 statements.
Why is that?
So-
I'm not understanding.
So return will basically tell Python, you want to stop with the function, you don't want to continue, and you return a value. So it says print something, then Python sees return, and Python says, okay, you want to return, we'll stop with the execution of the function.
It just breaks. So it just like breaks the loop.
Yes, yes.
So if your return was a higher number, would it do the same thing or would it?
Yes, in this case, yeah. Now this is a weird construction. You would never really put a random return in your function, but a lot of time you'll get something like this. So in this case, of course, it's a comparison. So in this case, it kind of says, oh, you want to stop? Sure, I'll stop. And if I say stop 2, it says, oh, you don't want to stop, I'll just continue. No. We've seen with ifs and for loops that if you can redefine the index from your for loop. And Jose showed a nice example where you have a book name, what was a women's name, and then you go in the list, you go over another list, and it kind of reassigns that name. That's called scope. The variable name is accessible before, after, and during the loop. Now functions are slightly different. If you use a variable in a function, it's only known in that function, so you cannot access it from outside of the function. So if I, for example, so we had the temperature in Kelvin, the function temperature, and let me scroll back to kind of refresh you. Temperature in Fahrenheit to Kelvin, we say temp K equals this, return temp K. Now, if you want to access this variable temp K outside of the function, it will give an error because it doesn't know what it's not defined outside of the function, it's only defined inside the function. So that's called its local scope. It's only defined in a certain part of your code. So if you want to, for example, in this case, you want to reuse the variable, you have to kind of redefine it. Now, the nice thing is that because the temp K is local and this is global, you can actually give the same name, but I would still kind of say, don't try to do this. So what this means, temp Kelvin, it's global, it means it's accessible from everywhere. If it's local, it means it's only defined in that function itself. Now, scope of variables can be tricky because you have to kind of really get the hang of it, what it means. And it's so, which brings me to something else. If you're writing a function, you want to know if it's correct and what it does, because imagine you're writing a piece of code and then half a year later or a year later, you go back and think, what does it do? So if you, for example, you calculate the average of a list. Now this kind of continues on the list functions from the previous session. You have a list of numbers and you add the sum up and then you divide it by the number of items in the list. So you have a sum, you go through all the numbers and the sum equals sum plus number and you return the sum divided by the length of the numbers. Length is a built-in function that gives you the length of a list. If there's 5 items in the list, it returns 5. So it's clear what this function does. It calculates the average over a number of numbers. And how do you test that? Well, what's the average? How do you test if an average is right? You just give it the same number and then the average should be that number, right? If you calculate the average of 5 once, then the average should be 1. So now this is all a very simple example, but you can imagine if you write 50 different functions and one of them is a type error. You cannot test all 50 functions, but it would be nice if you have simple test cases. This is the kind of a programming test for future. Sometimes you want to be able to test a function to see where the error is. Because imagine that I did a times number here. No, of course I suddenly see the average is 0. How can it be 0? And then I know where to go back. In this case, because it's a plus. And another thing is readable functions. Just like you want to not only use banana in a loop over books, you also want to do readable functions. Now, if you're a guru in Python, you just immediately know what this code means. It's just like, yeah, sure, that's the CA function, and it does this loop over, and it does a sum. But I don't think you don't easily see what this does. Now, if you do list function, you see a little help section here. There's good numbers. These two functions actually do the same thing. They both calculate the average. It's just in this case, you do this weird construction where you do a function in an anomalous function in the list, but no one really knows what this does unless you kind of dream of Python, which I wouldn't advise you. So what function would you kind of prefer to write, or what function if one of your colleagues comes with Python code and you have to go through it to see what's wrong, what kind of code would you like to see? I would definitely prefer to have this one. So we've seen the help function in the beginning. You can have your own help text in here. So you can refer to this later, but if you document your own functions, it's later easier to kind of see what it does. Because you may have 50 files of Python code and you cannot really find every function. You just type help calculate average, and then you're glad that your colleague wrote a little bit help. So the help calculate average here just shows help on this function. It shows you how to call it and what's an example. So like I said, the CA and the calculate average are the same. It's just that one is just much easier to read. Because especially when you make little errors, this can be a pain to debug. How are you going to debug this? If you want to print a value in here, it's just not doable. Because if you just want to say print sum, just to print the temporary variable to see what's happening, you cannot do this in this thing. So readable functions is crucial, because you're not writing code for now. In general, you write code because you want to use it later. You will always see that you're going to reuse your own code. If you're doing like, let's impress people, you're doing your Navier-Stokes integration. You look at online what it is, you write it out once, and you never want to look at it again. You say, well, I did that 2 years ago, I'm going to reuse it now in my current project. But what if there's an error in there? Are you going to debug it, all of your unreadable code, or you think, oh no, this is exactly what it does? So functions make it readable. If there's one thing that sticks, it doesn't make sure that it's readable. So the thing with functions is do it. So this we're going to do an example. This is basically about scope. So you have a value. You have a value that you assign 10. Now you have this function, my function, value equals parent return value. And then new value equals my function. So let's walk through this. You assign a value 10. Oh, actually, yeah. So new value, you call this function with the value 100. So you give her 100, you say value equals 100, you return 100. So this statement, what do you expect that it will print? So we have 10 here. Do we have anything else? Now new value is in this case, the param is 100, value is 100, return 100, right? And it's correct. Because this one has a local scope. And this one has a global scope. So you change the local scope here, but you do not change the global scope. This is sometimes confusing. And if you programmed in other languages like C, then where you have kind of in C, well, unless you specify, if you're not careful. So value here is local and value here is global. And here you only change the local one. So whatever variable names you use, be very careful what you're doing. Now, this is a nice example. Now we know 3 is even or uneven. So it says print is the number 3 even, and it calls the function even 3. Now, this will give an error. Well, actually it doesn't give an error, but it gives an incorrect result. Is the number 3 even? None. So how would you fix this? Could you fix this function so it actually returns false? Does anyone have an idea what's wrong with this code? You need an else statement, yes. So why do you need an else statement? Yes. Because what's happening now?
It's assigning everything to true.
It says the number. It's not an even number, so it will not go through this if loop. So it will fall through. And it basically says return none. There's no return statement, so it will return none. And there you go. Great. Now, do we need the else actually? In this case, we don't even need the else. Because if this is false, it will just false through So we will always know that if it reaches here, then it's an odd number. But an else is actually probably the best answer. Did everyone get that? So now we're gonna go in slightly more complicated example. So we want to have a function where you give a list as an input and it multiplies every element in that list by 2. So the result should be a list that's 2, 4, 6. So what we'll do is we build up a new list and we create a loop that goes every element, multiplies it by 2, and adds that to that new list and returns that new list. So what do you think? 3 minutes, 5 minutes? Let's see if I can do this in 3 minutes. How far is everyone with this exercise? So the first thing we want to do here, we get the argument values. We want to go over that, and we do for value in values. Now, the way I like to do this, if you have a list, I usually give it plural values. And then the iterator the fourth thing is the variable, is I use singular, so fourth value in values. And you kind of, you see the connection between values is multiple and value is just one. I find it for myself easy to kind of remember. So you go over all the values in that list. Now, what are you going to do with it? You want to multiply it, so you. But what do you do with that result? Remember from the previous sessions, you want to. In this case, you build up a new list. So you start with an empty one and you add that to the end. So you go from the first element in the old list to the last. So you start with append, so you start first to the end. And that's it. So if I run this. If I run it again. So this function, you can give it any length. No. Will this give an error? Actually not. But we're not gonna go in this. It actually, it adds two A's to each. Python doesn't say 2 times A is B. It just actually gives you 2 A's, but that's. So this was the function part. Did everyone kind of see what was going on in that last function? Did everyone get the core loop and the append statement? Do you have any questions about functions for me? The thing with function is you have to kind of, the programming in general, you have to do it to kind of run, to kind of see what the power, but functions make life a lot easier because instead of just writing a function, like an expression, a mathematical expression, everything you do makes it just cleaner if you just do it in one function. Make sure that it's readable, because you will always reuse your own code. If there's something wrong in it, it's easier to kind of check what goes wrong if you have a clear for loop instead of a weird lambda function list, blah, blah, blah. Python, Google, cheap, because it's no one writes Python perfectly. And the most important thing is you will get errors, but you also have to kind of figure out what they mean. And in that case, the next session will be kind of not interactive, we'll just errors and exceptions. So in Python, if something goes wrong and Python thinks I can no longer continue, it's what it calls we call it errors, but it's in Python language, it's called an exception. And it basically says, I'm stopping here. Screw you. This is where I was, and figure it out yourself. So this is a very basic example. We have a string and we want to add, so a variable can have any type, but when you want to mix them, you have to be either converting from one to the next. So if I have a string, which is our CIO, Jonathan, and you want to add a number, you cannot just randomly add a number to a string, you have to convert it to a string. So what this will do, it says type error, because you try to mix different types of variables. And it looks very complicated, but in general, the error is usually on the bottom. Type error must be string, not integer. And it will show you with this line number. It's in line 2, where you try to add this 5. And it basically means it must be a string and not an integer. Now there's functions to convert from integer to string, but we'll just not go into that. So what do you see in this? It's like type error, some gobbledygook where it points to the line number with the error where that error is, and then gives a little bit more description of what's actually expected. So that is a traceback. Traceback is where it shows you all the places where a function has been called up to where the error occurred. Now, in this case, it's easy, there is no function calls. That's why it kind of says the error is in line 2 and the specific error is in string and not integer. So what is it, like I said, is this type error. It shows you where the error occurred and what Python was expecting, like it had to be a string. It sees an integer, but it has to be a string. So that's the traceback is like that, just blocks of code with errors where it exactly happens. So let's take that calculate average function from the previous session. It calculates the average on a list of numbers. And how it works, it makes a sum of all the numbers and divides by the length of the array. Now, what if you give an empty array? The length of an empty array is 0. So if you run this with an empty array, I gave the fixed version. So I already put a solution in the spreadsheet here. So here, this is the function from the previous session. We get exactly that. I give it an empty array, empty list. It tries to sum over it. Well, there's no numbers in number. So it will sum stay 0 and the length of the number is 0. So it will try to do a 0 division. So let's see it look at this list. As you can see, there's like multiple entries. So we go top down. There's a 0 division error, which is like the beginning. This is the first one. It's where it's what happens. And then it goes where, so it goes from the start to the last function where the error occurs. So where the actual error occurred is always at the bottom. So if you see a long list of Python errors, scroll all the way down to the last one. So in this case, it's on line 14, return sum, and the error is division by 0, which is expected because len numbers returns numbers. So I kind of already left that solution here. The easy way to solve this is if there's no numbers in the list, we can print an error without a caps lock. And here we come into that return statement. We can return 0, but 0 is not a value, is not good because empty list doesn't have it. So in this case, we just return none. None, but it means stop here, don't give a value back, just say none. And calculate average in this case doesn't print anything because Python is smart enough. If it's none, it will not do anything. And the average of 5 and 5 is. Now, like I said, these tracebacks can be very long. If you're using all kinds of libraries or using a lot of functions, then you might end well with like 8 or 10. So in this case, we're going to create a little bit more longer thing. This is the same example where we started with. You're adding a number to a string. In this case, it's all hidden somewhere behind. So as you can see, I'm not sure if you can see the whole thing, but so it starts with the same type error. You see at first, the bottom says this is where the actual error, word equals word plus number. And you can kind of trace back as in the function add number. And it occurred in the add number this, and it changed something wrong. but the error stays the same, must be strict, but it suddenly looks a lot more complicated, but it's not. It's just goes you step by step through which function calls which function calls which function, where did the error occur. So the error is in word equals word plus number, which happened in the change something, which happened in the main part. Now, there's a lot of different errors that you can get in Python. One of the ones that we saw in the previous section where we redefined a function was int type is not callable, basically meaning you have an integer type and you try to use it as a function. So that you have an integer, you cannot call an integer as a function. You cannot say 5 bracket 5. But the most common things are in for example, in here. So this is one that you will, when you start programming, you run into a lot. Invalid syntax. Unfortunately, it doesn't give you anything more. But with everything, if you define a function, if you define an if, or if you define a for, you always end with a colon. Colon indicates to Python that there's a block coming. In this case, it was expecting a colon and didn't give anything. And this is a very common error that a lot of people, including me, make all the time because it's very easy to get the colon. One thing you often also, and this in Notebook, in Jupyter Notebooks, you will not run into this a lot, but Python is very pedantic about indents. And sometimes it's very easy if you program with VI or whatever simple editor to mix spaces and tabs. And like I said, in Notebook, you don't really have that, but in regular Python, if you mix spaces and tabs, you get a lot of this error. And takeout is very easy to recognize. Unexpected indent. So what you see here, you have the function add2, which adds 2 numbers, and the return C, except there's a weird space here. It's still voila. So this is one of these errors that you run into a lot. You forget the colon or you do the indent wrong. Now, in this case, it was very easy to kind of spot. But if you have a for loop and you do the last statement you indented, then it's part of the for loop instead of the last statement. But you will have to check the indentation, make sure that's right. Python is very strict about indent. Now, sometimes this is the same issue where you redefine variables and then scope is kind of unknown. So what scope is bad at? So do you expect it to be 5 here or 12? In this case, because it's a local variable, it's 5. But what if you expect something else? So here is like in the other example, beta is a local variable that's only known in the regress function, but outside it's still 12. So if you don't pay attention to the scope of variables, now this is not so much a syntax error, but it's the same thing that I've seen at the beginning too. Variable names are case sensitive. And so here, name world is not defined. And if you look through your code, world is local lowercase. Here is. So it's paid and the same with functions. Print, the print function does not start with a capital P. It's lowercase p. Same. Here we'll say function P is not. Print is not defined. No, there's other things like if you have an index, so you have a list of five characters, and there's like, for this case, 3 books. What you want to print index 3. No, Python, some other language, you started a list with index 0. So if you want to have the 3rd element in the list, you have to use index 2. Now, at least this is a very clear error. So in this case, list index out of range, and it showed where the thing is. So you made a little error that says. The third book in the list is Python. Now there's a whole list of variable of errors. Most of them you will not run into. Hopefully you will not run into OS error or like a unbound local error. Well, some of these might, but in general, most of these errors like zero division, value error, memory errors if you run out of memory, they're very easy to spot. But the trace back can be very confusing. You just always scroll to the last part, and that's where your error goes, what actually went wrong. And you can kind of trace back to see if there's a wrong variable. So that's a kind of a trace back. So it looks complicated, but it gives a lot of information. So, and that was session 3, and we're kind of ended a little bit earlier. So we're going to have our break now. We're going to break for 15 minutes. Yeah, so we're going to break for 15 minutes, and then we start with session 4 at 2:35. And if anyone has questions, please let me know if you have any questions about that.
All right, is the audio good? Okay, so we're gonna go ahead and get started with session 4. Session 4 is the final session in our Python Bootcamp for today. So we might get done a little bit early, but we'll have plenty of time. We'll have plenty of time after this session for extra questions. And a little bit of review if you want. So far we've covered the basic topics of Python. We've covered what the basic data types are, how you create variables, how you create functions, how you do the same thing over and over and over again, and how you can sort of encapsulate code to reuse it in functions. So now we're going to go, and also Paul covered a little bit about what to look for when your code breaks, when you have problems in your code and you run into errors. So now we're going to cover a little bit about how to actually go through and fix errors in your code. So fixing errors. So we have a technical term in programming for fixing errors. That's called debugging. Essentially, it's like going through. Essentially, it's like being kind of acting like an exterminator, going through and trying to get rid of all the bugs. So it's an old term that has been around since like the dawn of computing. So the questions we're going to have for this session are pretty much, how can I debug my program, and what do we do when the code doesn't produce the output we expect? And one thing to keep in mind is that debugging is not really the same as errors and exceptions. It is errors and exceptions guide your process of debugging your code. So essentially, the basic steps in debugging a code is when you run into an error, or when you run into a program that's not acting the way that you think it should, you want to find a simplified set of data, a simplified test case where you know what the answer should be, and run the code on that data. If it doesn't give you the answer that you expect, then you have a problem with the code, and we need to go through that. The other thing is, if you're doing physics-based simulations or like engineering simulations where physics is actually really important, then one of the things that they'll tell you to do a lot is check your conservation laws and make sure things like, you know, the total energy of the system is zero. Make sure that conservation laws hold. And the other thing to do is visualize your data as much as possible. My former advisor in graduate school used to say, plot the heck out of your data. So anytime you can make a graph out of your data, anytime you can make a picture out of your data, you want to do that because that's going to give you a way of actually looking at the data that you're putting into the function to make sure that the data going in is good. So a couple of simple guidelines for debugging is when you run into an error, when you run into code that doesn't act the way that you expect, try to make it crash, try to make it fail, because you want to see all the possible modes of, you want to see all the different modes of failure that you can have in the code. You want to see where, and you want to try and see where the most common point of failure is. You can see that, and you can tend to see where these errors pop up in the traceback that Paul mentioned. So you want to see if the same line of code is always the error, is always where the problem is. You also want to try and make it fail fast. So if you're running huge simulations with lots of data, try and find a really small test case that will run in a few seconds that will have the same error. Also, when you start going through the code to debug it and start to fix it, try to only change one thing at a time. So change one little variable, rerun the code and see what it does. Then make another change, rerun it and see what it does. The reason you want to do that is because if you make 5 or 6 changes before you run the code again, you might not know what fixed it. You might not know what fixed it, or in the cases that I've had plenty of times, you might break it worse and you might not know why. So it's really a good idea to change things one at a time. So that way, if things start to get worse, you can change it back really fast. And that goes hand in hand with the last guideline, which is keep track of what you've done. Yes?
So I guess I'm thinking in other things like there's Control-C to go back the steps. There's no, that does not exist here, right? So
actually, in most code editors, Control-Z does exist, so you can do undo, but you only want to have to do Control-Z once or twice at a time. But yeah, Control-Z does exist in most editors, but not all of them, so be careful with that. In most cases, it's best to either keep a list of the changes you make, or make little comments every time you make a change to know where you made a change. So we're going to have a couple of exercises that we're going to go through, take a piece of code that I intentionally broke, and we're going to fix it. So in this first exercise, this code produces the same output no matter what I put into it. So what this function is supposed to do is it's supposed to calculate a patient's body mass index. And that is dependent on a height and a weight. So I have a function here that takes in a height and a weight, does some math on it, and returns me a number. But whenever I go through here, I always get the same number. So the first thing we're going to do is figure out why. Can anybody give me an idea of what we might want to try first to try and figure out where the error is? It's okay if not. Just kidding. Huh? We can check that. Although that's a very good first thought, but the reason that's not a problem in this case is because indentation would have created a problem. Watch what would have created a different error. Watch what happens if I change the return here to 3. Notice how the tab here from a tab to 3 spaces. Notice how return has red on it. If I try to run this, it'll still work. Okay. So Jupyter I'm actually really glad you brought that up, because this is one case, this is one thing where Jupyter is really, really nice to you in cases that many other code editors are not. So Jupyter will automatically notice, hey, wait a minute, there's not enough spaces here, there's not enough tabs, and in the background, it'll do some magic and fix that for you. If you're trying to type this code into something like Visual Studio Code or another, or like just Notepad, it will not do that. It will throw an error that says, hey, you didn't put enough tabs here. Fix it, please. I'm not going to do it for you. So I'm glad you brought that up. Thank you. So tabs and spaces are fine. Any other ideas?
I mean, you could limit. Like you could adjust the number of variables in your list for like patient height and weight.
That's a good idea. Let's try that. So you notice how patient height and patient weight have three different possible values. Well, let's comment this out and let's change that so that it's only one value. Let's say we have 2.5 for patient weight and 3.4 for patient weight. And interesting. Oh, okay, so here's an interesting error. So it says object of type float has no len. This is actually a very interesting thing. So the way that I wrote the function, it is expecting, so the way that I wrote this for loop to go through all the different values, it's expecting a list. I try to say, okay, take the current patient number of the list as an index of the list patient height and put that into the function. And I do the same thing with patient weight. However, what I did here was I just turned those from a list into an individual number. So that indexing function will no longer work. But what I can do, this is a little hacky, but it'll work, is I can just put brackets around these. And all of a sudden it's a list. But now it says list index out of range. And that's because, and we're getting closer to what? We're getting closer to the error. Notice, now this is actually really interesting. Now it's saying list index out of range, but the list is only one item long and I'm supposed to be going through the list. Well, that doesn't make sense. Right. So one thing we can do is, and this is a good idea to do, is check and make sure as we can print our variables. The print statement we covered in the first section is very, very, very important. So in this case, let's print all of our variables and make sure that they're actually doing what we expect them to do. I'm going to change patient weight and patient height back to their original values. And let's print out what I is. So I should be an index going through the list, going through the list of possible indexes and patient height. Okay, so we get 0, 1, and 2, which is right. But we're still getting the same number for every time. Well, let's print out. So let's make sure that we know what each variable is. So I here equals, this will let us know what I is. And let's print patient number. Notice how patient number never changes. And that's what I'm using to index the list. Well, that's kind of an issue. Maybe I'm using the wrong variable for indexing these lists. Maybe instead of this patient number thing, I should be using I, which is something that changes on every iteration. So let's comment out patient number. Let's comment out these print statements. Let's see if that works. It works now. So what we did here, so just to review, what we did here is we noticed that the function was behaving weirdly. We were getting the same number every single time, and it was kind of confusing. So first, what we tried to do was we checked to see if it was a indentation error. And that brought us to some very interesting, some very useful points about Jupyter as opposed to other editors. Then we checked whether or not it was the for loop iterator variable that was the problem. And then finally, we checked the patient number the patient number variable, which is what we were using to index the list. And it turned out that that was never changing, and that was the problem. So the takeaway from here should be always print everything you possibly can. This is the if you don't have data to plot or make graphs of, this is the text-based equivalent of that. Print everything and make sure that the variables that are going into your functions, the variables that are going in, and the variables that you're using to index your data make sure that those are all correct. Do you have any questions for me about that? Any questions for online? Okay. So next, we have another exercise that's going to be kind of like this. So this code produces output that doesn't make sense. If I run this code, it gives me, so BMI is usually a value that's supposed to be a positive, relatively big number, like between, it's like between 16 and 35-ish. You can have higher, you can have slightly higher, you can have slightly lower. But all of a sudden we're having like 0.0003. Uh-oh. That doesn't look right. Can anybody tell me what the first step to fixing it, what I should do first to try and fix this? Huh? I mean, yes, you could do that.
Well, you have it looks like you have a math problem, so I'm good where you're doing your calculation. Make sure that varies.
Okay, next time I run this boot camp, I'm gonna make harder examples because you picked up on it you guys picked up on it too fast. That is exactly right, because this return statement is wrong. You were right, it's a math problem. So let's go through this and for completion's sake, let's check and see let's see if we can figure out where this problem came from. So we have the correct, so we have this for loop in the calculate BMI function again. If I print, the first lesson of debugging is print everything. So let's print the iterator variable again and make sure that that one's right. Okay. Okay, so this is changing correctly. And we notice that the BMIs that are being given to us are all different. So it's probably not an indexing error. Okay, let's go into the function itself and let's print out what the height is. That's getting put in as. Okay, it's putting in the right height. Let's check the weight. Okay, the weights look right. So it must be this return statement that's wrong. Now, if we look at if we go look up the formula for BMI, we can see that the formula is mass or weight over height squared. Oops. I put height over weight squared. So if I change this to weight over over height squared, all of a sudden I get values that make sense again. So the takeaway from that is when you print out everything in your, so the takeaway from that is basically if you print out everything in your function and in your code and all the variables and all the iterators and all the indexes look right, the next thing to check is your math. Because the next thing to check is your math. Make sure that the math that's going on in your function is correct. As an anecdotal story of that, when I was a graduate student, I was writing a MATLAB program for a homework assignment years and years ago. And I was working on this for hours and hours and hours and hours, and I was getting exactly errors like this. It was like I printed out everything. Everything looked right. I wasn't getting any errors, but the results that I was getting was just wrong. And I went looking and looking and looking and looking, and it took me 6 hours to find an apostrophe. In MATLAB, and that's a big deal because in MATLAB, an apostrophe is a transpose, which means you take a big matrix of numbers and you flip it on its side. I had forgotten to flip it on its side. And that was kind of a problem. So the lesson.
Even NASA managed to have the metric to imperial issue one time, so.
Oh, yeah. So math is very important. Always check your math. Yep.
And always check your data to make sure you have the data in there.
Yes.
I ran into a very similar issue of what seemed to be a very small problem, where I couldn't make my output match up with our resident statistician, who was way more well-paid than I am. And I kept going over and over and over, and nobody would help me figure it out. Hours of time, literal tears, just to realize that the data set he was using, because I use it from the original data set and then make changes from there. He had left out an entire column of data. And he was angry when I showed everybody else like what the error was, and I'm like, dude, I give you 6 chances to help me. So
Yeah.
always check your data.
Always check your data, always check your math. So the basic lessons of debugging are print everything, plot everything you can, and always check your math. It will save you hours of pain and suffering if you. So
make sure you don't comment.
that's it. That helps a lot too. Definitely don't comment out your, I'm pretty sure I've done that a couple of times too. Commented out a line of code and then gone back and tried to figure out what it was, only to find out, oh wait, that hashtag's not supposed to be there. So does anybody have questions for me on that? Or on debugging in general? Yeah.
So in the previous example, when you changed the patient number to I in the bottom part,
Yes.
could you have also kept in the patient number equals 1 and changed that to I, so it looks like it's what's different for the one below it?
I could have, but I would have had to do something. That's a very good question. I could have done that, but I would have had to change something else too. So I could have changed, so what I could have done is change this to, so changing this to I would not quite have worked because I is not defined outside that for loop. So what I would have had to do first is basically cut this line of code, move into the for loop, paste it, and then change it to I. Then it would work.
Below it.
Right.
Yeah, why don't you use patient number as the thing?
What?
Why don't you use the patient number in the form?
Because it was an easy example. Any other questions for me?
We have defined those variables like weight, height, and patient number. So where are these data? So are they stored in memory or in a data set?
Oh.
Somewhere?
For these specifically, they're going to be stored. These are stored in random access memory. So they're stored in the memory on your They're stored in your memory on your
So
computer.
actually, no data set is created at this moment. So I'm thinking,
sorry.
if we check the data, we need to have a data set to look at.
Right, so this is basically taking the place of that. So if you had a data set, if you had a pre-existing data set that you were trying to, that you were working off of, what you would do is something, you would either write out the individual columns as lists and then type them in yourself. Or you could read the data to Python using file input and output. I think we covered that in our intermediate workshop. But yeah, so this is basically a surrogate for a data set. So what we're doing here is just, we're making a data set on the fly here.
On the fly, it will disappear.
It only exists in this Jupyter notebook right now, yes. So in this case, checking your data would basically mean checking the variables, checking the variables we defined up here. And making sure that data works. If you're working off of a real life data set, you might want to open the data in Excel or something like that and check the rows and columns and make sure that those look right.
So how can we keep the history of the log? When you fix the error, you run again, so previous history of the log, it disappeared. You not see it.
In this case, yes. There is a way of tracking changes a little bit. It's not something that you do with Jupyter Notebook. That's actually a topic called version control. And there's a whole nother set of tools that are designed for that. If you ever look up GitHub or Git, that's exactly what that's for. It's for tracking changes. Does anybody else have questions for me? Okay. In that case, we're gonna go through a quick tour of some of the neat features of Jupyter Notebooks. We already saw one really nice feature of Jupyter Notebooks, and that's that it fixes indentation errors for you most of the time. That is really helpful because when you go to a different code editor, especially if you're editing code really old school in like a gedit or notepad or something like that, it's really nice to have these sorts of automatic indentation fixes. But Jupyter Notebooks have a lot of other neat features. One of the neat features is something called Markdown. So if you've ever heard of HTML, which is hypertext markup language, Markdown is sort of a play on that. Markdown is a markup language that allows you to do some really quick and really simple and really nice text editing. So for example, if I create a new cell using this plus button here, and by default, the cell will have a type code. But if I change that, I can change that to Markdown. And Markdown will now allow me to type regular Markdown, which will let me typeset some really nice. It'll let me do some really nice typesetting. So I can create a header. It unfortunately won't do spell check, which is sad because I need that. But I can also add things in here, I can also add 3 backticks here. And within these delimited 3 sets of backticks here, I can type code as if it were, and have it typeset like code in Jupyter. The difference is that the code that I type here will not be run. It's only for display purposes. So I can type for I in range when patients and print. And this will give me a nice formatted for loop. This is actually really useful. This is really useful in Jupyter Notebook if you're trying to, if you want to really explain each block of code. Or in cases like this, if you're doing teaching, these kinds of things can be really nice. Another thing you can do with Markdown is you can create and typeset formulas. So for example, if I have, you know, and I should mention that the formula typesetting style that Jupyter uses is something called latex. If you've ever used latex to do typesetting, Jupyter uses that style. So I can do something like, you know, weight over height squared. And as long as it's between those two dollar signs, it will typeset for me. And I can get this really nice formula here. And with Markdown, you can also just type regular text. And it'll get formatted in whatever the default font is. Another thing you can do with Jupyter is you can make inline visualizations. This is a bit of a more advanced topic, but this kind of goes hand in hand with plotting your function as much as your data as much as you can. So let's say we want to just make a plot of 25 random numbers. So we start with X and Y as empty lists. These import statements are importing external pre-written functions. Python has a whole bunch of extra packages you can that give you a bunch of extra functionality you can use. We can do XY here. We can do for I in range 25. X dot append I will append each number 1, 2, 3, 4, 5 up to 25. And then for each one of those indexes, we can generate a random number. Then we can just do plot XY. This star here will say, okay, I want you to plot this on a graph, but make it in stars. So scatter plot. X label, Y label, and then show. And what this will do when it decides to work is it will, there we go, is it will make a graph like this. Yes?
This code on the workshop accounts, they won't have matplotlib installed, so you'll get an error. So if you leave it and don't run it, that's the output that we did when we were running it the first time.
And you all can blame me for that because I forgot to install matplotlib. I forgot to put matplotlib in the script that set all this stuff up. So I apologize for that. So there
is how to add that?
yeah, absolutely. You can do that. This is another nice feature of Jupyter Notebooks. You can install packages using an exclamation point and do pip install matplotlib. And PIP is the Python package manager, and it will let you install external code packages. So, and then you'll get a whole bunch of output like this because I have it already installed for me. It'll do that, but it will give you you should get a set of outputs saying this is installing, downloading. You'll get a little progress bar. So there are a couple of important limitations of Jupyter Notebooks. They are not self-contained. So in order to make all this stuff run on the workshop systems, we had to do some setup. We had to have Python installed on our systems. We had to make sure Jupyter was installed using this PIP command, and we had to make sure that all the necessary functions were already pre-installed. If you're installing this on like your home computer or something, if you install something like if you download and install Jupyter Notebooks from the official website, it should come prepackaged with all that for you. If you go to the Anaconda website and download that and download Anaconda's Python version, it'll come with all of this pre-installed. So just keep that in mind. Jupyter Notebooks are not self-contained. They need a little bit of infrastructure to run. Where it says here that session state cannot be saved easily, I don't think that's actually true, and I shouldn't have put that there. There's also some things there's also like no interactive debugging, but that's an advanced feature of other Python IDEs. So before I continue, are there any questions about the fancy stuff Jupyter can do for me? Okay. And lastly, we're going to cover, we're just gonna, hang on one second.
Yeah. No.
Fine. If I hit the download button, everything would have been fine. Oh, come on.
It was like.
Screen share? Do I need to fix that? Okay. Okay, so there are a couple of so for this entire boot camp, we've been using Jupyter Notebooks to type all of our Python code. But as a sort of last little thing, we wanted to make sure we told you that Jupyter Notebooks are not the only way to write Python code and to use Python. There's a number of different alternatives available for Python. There's some collaboratory alternatives available. These are things that are up in the cloud that you can share between different people, and you got multiple people working on the same notebook. Google Drive has an app for that. There's also Google Colab that's available. It's essentially a Jupyter Notebook-like environment, and there's a number of others. If you want to edit code, if you want to run Python on your local computer, all you need is Notepad to write Python code. You can use Python's built-in idle IDE. That's what you're seeing. That the Python idle shell is what you're seeing on the right hand side of the screen here. There's Jupyter Notebook as we've been using. Anaconda also comes with its own set of IDE options. So I've been inadvertently using this term IDE without explaining it. I'm sorry for that. But IDE stands for Integrated Development Environment. So IDEs tend to include, they tend to give you things like the code, the debugging, syntax highlighting, autocomplete, some version control built in. They also do, one of the nice things that they do is they'll do the code version of spell check, which is when you have a syntax error or something like that, it'll underline it and it'll give you a red underline when it catches that you're about to run code that has an error in it. It'll also underline it in yellow when there's a warning. For example, like when you create a variable but then never use it later on. So integrated development environments are really nice. There's a number of them available. There's Spyder, SPYDER, and there's also Visual Studio Code for Microsoft. So Sublime Text is another one that's pretty commonly used. Atom is a free and open source one that's available. If you want to go old school and you want to get really into text editors, you can learn Emacs. But that's like a whole, Emacs is basically a degree in and of itself. VI and Vim are similar. And then Visual Studio Code. There's also some more general IDEs that are available. Eclipse is a pretty typical, Eclipse is pretty typically used for Java programming, but it can be used for Python. PyCharm is another common IDE. The one you're seeing here is Spider. We also have that on RCC, but that's another free and open source one. Thani I've never used before, but that's another one that's available. Anaconda Navigator. If you install Anaconda Python on your home computer, it should actually come with all of these options. You'll have Jupyter Lab, which is basically a slightly beefed up version of Jupyter Notebooks, with some nicer features. You'll have Jupyter Notebooks, you'll have Spider, and you'll have IPython, which is another notebook-like interface. And lastly, if you don't already have all this stuff, we'll send these slides along with the solutions for all the notebooks out after the boot camp. So what I have right here are a bunch of just links for like ways you can learn more, different references for Python in of itself, and different notebook cheat sheets. So are there any questions about Python, about any of this, or about anything we've covered in the notebook, or anything we've covered in the boot camp entirely for us?
Which one do you use?
I tend to it depends. I use Jupyter Notebooks a lot, but I also tend to use Visual Studio Code, and sometimes I'll use gedit, which is just it's basically like Notepad for Linux systems. But I like Visual Studio Code because it does a lot of that syntax highlighting. It catches errors before I make them. Any other questions for me? Yeah.
GitHub could be like a notebook or not really?
I'm sorry?
GitHub could be like a notepad, like notebook or not?
GitHub?
Yeah.
I don't know about that. I think GitHub can host notebooks, but I'm not sure off the top of my head. I know you can store notebooks and all that stuff there, but I don't know if GitHub has an interface to run them. Yeah.
So in our office, we use Snowflake quite a bit with SQL coding, and there's the ability to have Python worksheets. Have you had experience with Snowflake at all, or?
No, not really. If you ask Casey McLaughlin outside, he does a lot of SQL, so he might have heard of it. Any other questions for us? In that case, you get 45 minutes. You get 45 minutes back. Oh, yes.
So how do we find out about the intermediate?
That is another. So the intermediate Python workshop is another one of our workshop series. And if you look on rcc.fsu.edu or on the FSU events calendar, it should be on there. It's March 21st, you said? Yeah, it's on March 21st. Marcelina, is it in the same location or is it in? I'm sorry?
Yes.
Oh, it's here? Okay, cool. So it's in the same, so March 21st, same location. I think it's 3 to 4:30. Oh, 3 to 4:30. Huh?
Different level?
Huh?
Different levels. So today is the basic.
Yeah, this is a bit more, this will be a bit more intermediate. The intermediate workshop, the intermediate boot camp will cover a little bit more in-depth functions. It'll cover more in-depth lists. So there's a lot of different things you can do with lists. It will also cover file input and output, so how to read, so what we were talking about a little bit earlier, how to read data from a pre-existing file into your, it'll cover how to read that into your Python environment.
May I get the materials from today, the whole materials.
Yes, absolutely. We'll send, so after today, we'll send sometime later this week or early next week at the latest, we'll send a recording of this workshop along with all of the notebooks and these slides.
And these stay active for another 30 days.
Until the next.
Until the next boot camp. So it'll probably,
Wait until the last vote.
Do you know when registration opens for the intermediate one?
that I do not know. I really don't know. I think you can click, I'm interested in,
The
if
button
you,
wouldn't work, so
Huh?
the button wouldn't work.
then I would send us, send a tick, then send a, let me pull this up and share the screen.
Write a Python script.
Yeah.
That will
Yeah.
then-
I have to prove that I can do the intermediate.
So if you get errors like that, send an email to this email address. This is the RCC support email address. And let us know that you want to be on, let us know that you want to be there, And if there is a sign up process, then we will make sure that you're on it.
Confirmed by Casey and we'll open tomorrow.
Oh, okay, so it'll open tomorrow. Thank you. Casey's the one that usually manages that stuff. And also, if you have any questions about stuff from today, or for some reason you don't get the materials, please send us an email at this support email address, and we will make sure to send you all of that. You can also email that support email address if you want to get a permanent RCC account, so you can use Jupyter Notebooks. And so you can use Jupyter Notebooks consistently. RCC accounts are free for everybody. So don't worry about that. The only thing is you would need to pick, if you're a student, you would need to pick a sponsor, which is usually your graduate advisor or your PI or something like that. If you're a faculty or staff, then you're good to go. Yeah,
What about postdocs?
I'm sorry.
Postdocs?
Paul, do postdocs? Oh, come on.
It's either faculty or other.
Does that RCC account come with our studio data too?
Oh, yeah, anything that you see on Open On Demand is available to anybody, is available to you. Yeah.